Hi, colleagues. Good morning.
Hello, good morning. Okay, maybe we just wait 1 or 2 more minutes. So I think we are getting to almost, yeah, quite like 20 participants, right? So okay, shall we start or should we wait a bit more?
Let's wait 1 minute more and we can start.
Hello, good morning.
Hello, good morning.
Question, Poria, are you going to record this meeting?
Yeah, it's going to be recorded, correct.
Thank you.
Thanks, dear. All right, seems like now we're getting to 25. Okay, so should we start slowly?
Yep.
Yeah, okay, so let's start. So good morning, everyone. Thanks a lot for attending this session. So basically, the idea is to kind of have I think, if possible, a series of let's say educational sort of if I may use this word, basically, sort of workshops together to build a sort of common understanding. Just sorry. Oh yeah. So I thought this is okay. To build to make, let's say, our point of view a bit closer to one another and try to get a better understanding from those domains that we are not necessarily expert on that particular subject, right? So and I think with this effort, basically, we can just try to build a common language in a sense that when we are working in our particular domain, we could also keep an eye or keep in mind, let's say, what is going on the other domain, and actually try to better design our activity. So if I may share my screen. For this purpose, I suggested this workshop, basically. I mean, if we find it, as I said, useful, maybe we can continue. How can I do not mirror my video? Yeah, no, sorry. How can I remove this? Yeah, okay, maybe. So, sorry, George, do you know how can I remove this? Or can you see me now here in the...
Yes, I can, but I can't see you in the presentation mode.
So, but you're seeing me also, like my picture here too, right? So you're seeing the videos. I want to see how can I minimize. Okay. Oh yeah. Okay, I did it. Thanks. All right. I put it on the presentation mode. So yeah, sorry. I was saying that yeah, the idea of this session is just to have basically a sort of I wouldn't say like educational, but like share my own perspective mainly with you all to see like how um, I see uh, not the project itself, but the 5G part of the project. So to share it with you, of course, these are my personal understanding, my personal, let's say, knowledge. So maybe it's not completely correct. So maybe it's not, let's say, it doesn't cover all the domains, because, well, I mean, obviously I'm not, let's say, the expert of everything, right? So but the floor is open. I think it at least opens up the room to talk further, to share our opinions further, and see how we can move forward together. And as I said, if we find this sort of let's say idea exchange, or let's say point of view exchange useful, maybe later on in the future months we can plan a similar workshop for the other topics of interest. It could be something about OPC UA, it could be something about, I don't know, the IEC platform, so on and so forth, or any other topics that we think it's worth to be shared with the others, and then to be discussed and further being elaborated, right? So that's the purpose of this meeting. So again, this is not necessarily a direction for the project. It's just like to express how I see the particular layer of the project, and check with you if you agree. If not, if you want to, let's say, add something, and basically serve as a floor to discuss further. I booked already 3 hours for this session, but I don't think we need 3 hours. But just in case, because I could not predict let's say the Q&As, or basically the open discussion, I just decided to book a good number. So far, is there any question or doubts related to this session, to the points that we are going to discuss, or not? Or should I move forward?
I find it is a good proposal, Puria, that we do this in that way.
Okay, thanks a lot. Thanks a lot. So again, just please keep in mind that most of the things that you would see, it's just my personal understanding and my personal, let's say, uh, knowledge, right? So it might not be 100% accurate. It might not be completely correct. And well, I see in this floor we have like basically different experts with different domains of a specialty. So I mean, if you see something is wrong, please raise your hand or just jump in and try to correct me, because it's not written on the stone. It's just like yeah, it's just my understanding. So maybe I'm also in a kind of confusion or misunderstanding. Okay. So we will do basically a first round, which is basically some slides that I present. So it's just I try to find the title for it, and it was a bit difficult, but I decided just to put the title like different perspectives and how to bring them close together. And then at the end, we will have an open discussion if it's needed, right? So all right, so let's start with this. I mean, this figure, I like it a lot personally, and Commission published this picture in the beginning of 5G, basically when 5G was coming, and it was like a big thing, and everyone was just like talking about it. So I find this picture quite informative, because it shows basically what we are talking about in a very abstract way. So basically 5G is about the cellular mobile communication, right? So when we are talking about cellular mobile communication, we are talking about cell phones, right? So the first generations up to the fourth generation, the main focus, the main paradigm was to serve people, right? So it was mainly to provide a better, faster, more reliable service to the end user. And in this case, this end user was only basically the people, right? Ourselves. But then with 5G, there was a paradigm shift. So not only people became the concern of the mobile operators or the cellular technology providers, now things became a new dimension to be served, right? So and this is where we are, and this is how the paradigm of cellular telecommunication has changed. So not only people are main concern, but also other things are also a part of the concern, and they want to serve them, right? So just in parentheses, when we are talking about cellular communication, just to put it super simple, is basically a sort of communication that we put a SIM card, right? So we're talking about this type of communication. And of course, among those things, basically industrial, let's say, use cases or scenarios are an important pillar. That's why you would see there are some associations working on how to bring closer the cellular players, mobile players, with the industrial, let's say, automation actors, or let's say other, let's say, partners involved in the ecosystem of industrial domain, like 5G ACIA, which is one of the most famous or reference, let's say, associations in the world. So, but this is the framework. This is just like a kind of conceptual change that has happened in the world of mobile telecommunication, right? And then after 5G, any other generation will build upon that. So we will enhance these two pillars of people and things. Just again, in parentheses, like any other businesses, if you can think about like how to keep your business continuous, basically, you would realize that for mobile operators, for telecom vendors, it was like a natural choice to start with people first, even in the 5G era, and then move to things, right? So that's why when we came from 4G, in the beginning of the 5G, the first releases, still the main concern was how to serve better, let's say, people. And that's why, let's say, the mobile broadband services were the one that they were picked first. So, and then we are moving to the other domains. So like mission critical, and let's say massive type machine communications, which are more concern of verticals, right? So because this is the logic to not disrupt the business of a sector completely and start with something that would look like a kind of a pause and then a restart, right? So that's why many of the releases, the first releases of 5G, so the way that it works is like you standardize, you just put some equipment, then you can do a new installation based on these new equipments. Probably the release 15, which was the beginning of 5G, you still see things on the EMBB side rather than things like the solutions related to the, let's say, lower latencies or mobile machine type, let's say massive machine type communication, right? So just these are some clarification at the very high level. I think, yeah, there are many people that know this more than me. So, I mean, I think we have a lot of 5G experts already in the call, but just to share this perspective from those that are not so much coming from the, let's say, cellular mobile communication world, right? So any question, doubt so far? Is it clear what I'm saying here?
Yeah, clear.
Yes,
It's
yeah,
clear.
absolutely clear.
Exactly. So now, I mean, we have this concept of things. And as I said, one of the things is basic, or the way that the mobile, let's say, cellular communication people would like to call them, they call them verticals, because they are like those type of clients that they come and sit on top of your infrastructure, 5G network infrastructure, and you serve them. So that's why they call them verticals. So like you have a horizontal network, and then different verticals come and sit on top. So basically, the vertical of industrial automation is our client, and we need to serve it, right? So it's not the other way around. So we should not push 5G to their world. We should find out how we can serve them. And this is something that I would like to stress here. So although our project is also about 5G and adaptation of 5G in industrial automation, we should not force 5G to everything. We should find where is exactly the gap, the place that 5G could make sense and serve this client, because this client is like any other type of client, has its own world, and it has its own, let's say, businesses, other things of concern, right? But one of the tools that might be helpful for him is or him or her is just the 5G mobile cellular connectivity. So we should find a perfect spot where these two words can overlap and make sense, and then work on let's say, how to introduce this cellular communication in the world of industrial automation in this case. So first step is to better understand what is going on there, and as much as we can understand, because we are not expert of that domain. So we here is the 5G guys, let's say. So I did some studies, and I found out this pyramid, probably there are more experts in the call that they understand better this pyramid better than me, and but this is my understanding. So I figured out there are two types of communications, so horizontal and vertical. But what is mainly important for me are these two pictures. I mean, yeah, first clarification. I figured out that the word communication could be a bit confusing for ICT people, for people that are working with telecommunication, and those people that are coming from the automation. So I rather to, instead of using communication here, I say like data and information exchange, because people might get different understanding. When we talk about communication in the ICT world, people might directly go to, I don't know, putting up the network, I don't know, just setting up a connectivity from A to B. I know it's related to data and information exchange, but my understanding is the main focus is just like how, let's say, information and orders are moving in a big picture of industrial automation. And for this, probably the main part that we as 5G could help is probably this side rather than this side, because of the time scale of the decisions and information exchange. So you can see that in the very higher level, there are like decisions are taken on, or actions are taken in a monthly basis or daily basis or hourly basis. So here, basically, I don't think we really need a complex, expensive system to connect the data from one point to another because we want to make a decision every few months. So I don't see, personally, I don't see it that much relevant here. But there are things here that are in order of millisecond, microsecond, even seconds, that might be relevant for a more advanced, let's say, wireless communication that could be adopted in the industrial automation world. So to help them to come up with some extra benefits for their domains. Maybe by removing some cables, they can just have like more flexible, let's say, production lines. Or maybe they could have some AGVs running in the shop floor, right? So probably this is a more relevant domain for a system like 5G, which is basically an expensive system after all. Even either you rent it or either you deploy it yourself, to be adopted and to be used. So, and then when we look at this, we see that even today in the wired world, so in the wired type of, let's say, network that is used, there are some particularities in the industrial domain that are used, which are a bit different from the normal internet as we know, right? So there are some particular protocols that are used for the exchange of this information and comments between controllers and the field level, let's say, items, rather than the way that my cell phone tries to reach out to the Twitter, let's say, server somewhere in the world. So, and this makes it quite interesting to work on this domain. And I think this is like a cornerstone for us to better understand. So to just conclude, I think the main part, I mean, this is exactly my perspective. So the main part that 5G or system of 5G could work or could bring benefit in this domain is basically this layer. And then we can check where it makes sense, how it makes sense, and how this adaptation should be done. And then we can talk also about ownership, like, does it make sense to be a private network? Does it make sense to be a public network or a hybrid network, so on and so forth. So but I just wanted to kind of highlight this borderline, that where this new technology even could fit in this new world of industrial automation, at least from my perspective, and how we should treat it and why it's necessary, and so on and so forth. So do you agree with this? Do you think that what I said is not correct, or any other objections or points of view that you would like to express in this slide? No? All right. Okay, let's move forward. So when we look at on that particular layer, basically there is a kind of internet perspective that exists today in the factory shop floor. And when I say internet perspective, it's just like because it's mainly the wired technologies, right? And if I may just highlight, probably in this wired ecosystem where 5G could sit or could be useful, probably I can just highlight those red boxes. So basically, 5G is not about like the application layer itself. So here you could have, I don't know, platforms, and top of the platforms, you might have some application running that is consuming data to visualize something, I don't know, to do whatever. But 5G is mainly about connecting one system. It could be a laptop, it could be a PLC, it could be, I don't know, a controller, whatever, to another one, right? So it's just like, I mean, instead of having an Ethernet cable, an Ethernet, let's say cards and cables, you could have a wireless system. So basically, when we are talking about 5G, we are talking about this networking layer, this data link, this physical link, right? So this is where things get really connected to one another. So if we put it here, if these are the PLCs in your shop floor and these are the controllers, basically 5G is mainly a solution to replace these these switches, these industrial switches in your shop floor. And nothing else, right? So we are not on the application itself. We are not on the, I don't know, other layers. We are just mainly on this connectivity part, how you connect one point to another. So the information and the data generated by the controller or by the device could reach one another. So just to make it clear, again, a sort of boundary when we are talking about 5G, what exactly we are talking about. Is it clear again here? Is there any comments, questions, doubts?
This is very clear, Puriya, and it
Okay,
really
excellent.
helps us to visualize where the 5G fits.
Actually, I have a question
Sure, please.
because you on the right side there is the red box around the PLCs.
Okay.
So
Very good point.
my question is now the PLCs are most of the time part of the machines, meaning they are boxes next to the machines and they are wired. And they need this very short reaction times. And I think what I have heard is that with 5G there is no chance of realizing those very small reaction times because it's like immediately.
Exactly. Yeah. Very good point. So I already forgot to say. So I put this part a bit like with careful, with caution, because yeah, probably we should not go that far to put 5G. Yeah, it's a very correct objection. But yet again, since for example in this project we have also maybe it's better, it's safer to put it like this. Yeah, I was a bit like not completely sure to put to let's say to have this red box a bit closer from the PLC to the device itself, yes or no. But I just like said, okay, let's try and see. Maybe there might be some cases that let's say a wireless connectivity can even serve there. But yeah, you're right. In principle, you are completely right. So it's better to play safe, let's say. Yeah.
Because I know that there are ideas for a complete virtualization of PLC and so on, but I think up until now they are not that far. They cannot really do this
Exactly.
right now.
Yeah, no, definitely. So, but maybe this could be one of the points for us also to further investigate and see how we can pave the way for this future. Let's say when we have like the virtual PLCs and a wireless connectivity to serve the connection. So, let's say today with the current devices, with the current releases of 5G, we cannot do that because just to quickly come back here, I said uh, the main concern for mobile communication business was still in the beginning to serve, let's say, people. So release 15 and release 16, I mean, Andre and others are also in the call, but again, the main concern was EMBB. So it enhanced mobile broadband was the main focus, the main concern. So the main devices are yet thinking about providing a higher bandwidth in your equipment. rather than providing you a lower latency. So probably from release 16, 17, and 18, we would see more, let's say, type of solutions or devices that could serve the fast and low latency communication, right? So that's why with an equipment that is related to release 15, you cannot yet do this, but probably in the future releases we can foresee at least stepping towards that goal. And I think our project is in a good position. I mean, on the study side, it's in a good position to pave the way for that future. I don't know, Andre or other colleagues from Huawei Online, do you want to comment something on that?
May I comment, Purya?
Please, please.
Yeah, I agree that with the current system technology, this is not feasible. But I would say that we should quantify. I mean, what is this immediate means? I mean, what is the time delay that we are talking about here? Because it might be that definitely now it's not feasible, but then if there's a set of PLCs that this immediate means a few milliseconds, then it might be realistic. So I think that what we can do is that all we need is to quantify this immediate. What does it mean in practice? And based on that, then we can decide what is feasible, what is realistic now, and what might be deployed or realistic later.
Absolutely. Totally agree with this comment too. Yes, absolutely.
Point also
May I?
industrial automation perspective, maybe. Or-
Marius,
No.
could you please speak a bit louder, please?
Is it better now?
Yeah, please.
Okay. So yeah, first of all, let's not get into the point that industrial automation means always microseconds level cycle times. That's first point here. I agree that in order to cut something very precisely or to put, I don't know, labels on bottles or to create some sort of a mobile phone which you put it together and you need some kind of small robots moving there and taking parts and so on, you need you need to do position control and you need to do let's say millisecond level or under millisecond level cycle times for those closed loop control or open loop control. There are also applications which you don't need to do that. There are conveyor belts. There are, let's say, I don't know, big ships who have some kind of equipment which needs to move. There are pumps and there are, let's say, mechanical things which you simply cannot. The mechanical system cannot react so fast to let's say to a sort of a to such a fast communication coming from the PLC. So that's first point. So that we should think about us, that where to position the 5G in relationship with the cycle time of industrial automation applications. That's something which is, I think, very much of a key aspect here. Then you can think on serving better an industrial automation system if one cannot make it. For example, there is a system which is a complex one, has somewhere there are some part of a system, there are cycle times which are microsecond level, there are some part of the system which are seconds level of cycle times. So maybe this kind of system have to live together, so then can be connected together, and then 5G can support connecting them together, and in some part of the system going even lower, supporting, let's say, those cycle times which are not so small. So 2 points again here: positioning of the 5G capabilities in terms of industrial automation cycle times, and second of all, deployment. So where can it be deployed and what can it help really by such a deployment? I mean, one should not always say that it has to be deployed in each and every device, but also not say, yeah, it has to be only in only one device in the plant and that's all.
Excellent.
Thank
Thanks a lot. Thanks a lot for this good point. Any other comments here?
Yeah, sorry,
Yes,
it's me again. Yeah, so I think that I'm mainly following up on Marius. One of the things that we need, or in my opinion, we should address in the project is that, okay, we have a set of requirements or needs into this industrial domain, but then we need to be somehow realistic. We need to understand what are those requirements and which of those can really be performed with 5G, because I mean, it would be bad if we make the error that, okay, we see a nail and then 5G is the hammer for everything. So we need to see what is the requirements and the scenarios that this technology might help, but then take into account also, I mean, what is realistically to be deployed, or where this technology can be realistically be used, because otherwise we will go into a bit of a very sort of theoretical usage of 5G, where in places that it does not make sense. So I think that we need to understand what are the requirements, what KPIs have those requirements, and whether 5G makes sense to be added into those.
Absolutely, I totally agree. Yeah, I mean, especially with this comment, I like it. I think you both also resonated on that like 5G is not a hammer for all nails. Yeah, it's very correct. So I think we should be completely honest and make sure that first of all, what we are talking, is it just like 5G? What 5G release 15 can serve? So this is one thing. One thing is like what 5G as a general, let's say, solution, even with the future releases of the equipments might be able to serve. So maybe today it cannot, but yeah, I mean, this is doable for 5G in one future release. So, but there are some cases that I think 5G or probably even 6G could not serve. So I mean, we should be honest about those two. Like, look, I mean, if you want to do this, probably this is not for you. It's just like you should find an alternative technology, or maybe use wire, because this is not possible, or at least it's not possible immediately in the next 10 years. So I think we should be clear on that. Yeah.
Yeah, Puri,
May I comment?
Can I comment a bit?
Please.
I think maybe we can go first to 3GPP specifications, in particular in TS 22104, where these KPIs and their values are defined for industrial use cases, at least for some industrial use cases. And then we can see target what 5G can support. For different use cases, there are different values what 5G can support related to latency, availability, reliability, data rate, and so on. And then, okay, basically for many 5G was developed in keeping in mind 1 millisecond as latency, this lower bound. Of course, theoretically, this theoretical, I would say, low bound, and then we need, typically it's supposed at the radio interface, this 1 millisecond delay. But also, of course, core network will bring additional delay and processing information and so on. So theoretically, it can be a bit higher, but probably, okay, level of millisecond is reachable, yeah, by 5G. Of course, when for certain specific use cases, there is requirement like level of microseconds. Now 5G is not able to support this, at least as you said, this releases, yeah, well, what currently
Exactly
have finished, yeah. So, and then we need to be honest, yeah. So for instance, for motion control, okay, level of millisecond cannot be provided by existing 5G releases, yeah. So, but anyway, maybe it's good to do preliminary analysis based on 3GP specifications, what now is reachable by means of 5G, and what are more or less, and where are issues or where are gaps, yeah. So
correct. Exactly. So Andrew,
just
is it
to add on
possible
this,
to just sorry, Karim, 1 minute, and I give the floor to you. Sorry, Andrew, is it possible to to share this document later on after the call alongside with other colleagues. So yeah, okay. Please carry. Thanks a lot. Please carry. The floor is yours.
Just to add on these comments, I think they are all very valuable comments. I fully agree. The 5G fundamentally actually meant for the improvement on the radio part, especially using different spectrums. The 1 millisecond delay is actually now the ambition for the radio part, but the reality is actually it can be a couple of tens of milliseconds if really the server, the application is far. And if we reach below 10 milliseconds, it is already good. And in the future, if we really look for the advancements in release 18 and onwards, which will, I don't think, be in the market in the coming 2-3 years, we can still push the boundaries below 1 millisecond with using higher spectrums, like the wider bandwidths that gives us to use better subcarrier spacing algorithms and all these mechanisms. Maybe we can push the boundaries. But I think this aspect of bringing 3GPP's abilities also ETSI defines all these things and mandates 3GPP to standardize. These are actually the points to set, let's say, what 5G can do, what 5G cannot do. And delay is just one aspect. Beyond delay, there are also, Andre also mentioned perfectly, the reliability or the retainability of the packets, more precise, the packet error ratios. I recall some of the discussions in the past, like the number of nines after comma, like the packet losses, 1 out of, I don't know, 1 billion packets can be lost only or can be compensated if it is lost. So these things are going beyond 5G capabilities. And no matter which release, I think it's fundamentally not what 5G is meant for. And there, I think it's a clear border definitions needed for the use cases. But that, of course, doesn't mean nothing can be done with 5G. I am sure if the good classification on the industrial use cases, like Marius gave really good examples, like conveyors and etc. I think there will be plenty of use cases where 5G will make a lot of sense.
Definitely.
And maybe there will be some cases which is also good to know what 5G cannot fulfill. I think these will be also very good light for the 6G and beyond technologies to consider, okay, these are the advancement areas of 5G to address more and more use cases.
Definitely. And I think, I mean, in the future slides, I have some slides in this front, so probably we can also come back to this. But thanks a lot for very good comments. I think, I mean, I totally agree with all of them. And but again, I mean, I think since we are also an innovation action, it's better to be as much as possible realistic and see what exactly we can do and where it makes sense, because after all, yeah, I mean, this is not just like to draw things on the paper. So yeah, just another angle that I'm not sure personally I'm like super expert on, or I can just comment that much on that. But looking at this other picture here, right? And looking at this IEC, let's say, type of protocol and information exchange and the platform, and looking at these configuration parameters, I don't know how much this might be related to kind of configuring, because here the configuration orders are coming to a sort of LAN, which is Ethernet or serial, or it's just like I don't know, some configuration for TCP IP level. How much this could be mapped also to connect these automation platforms, if I may use this word. Maybe I'm using wrong word, sorry if it is, but yeah, how much we can try to map this platform level developed by IEC world into the future, or like 5G network that eventually should sit on this level. Is it something that someone might comment or might express some opinion, please?
Yeah. So when we did this field bus things in the IC, each company wanted to reach a number of use cases, or reach larger company, however you want. Let's say each group, let's say, wanted to reach a number of use cases, and some other join to those groups and so on. It's exactly the same discussion up till now, overall, say. Some of the some of the IEC specifications are meant actually to support use cases down to microsecond level. For that, they went that far into redefining their own MAC layer, like EtherCAT, like PowerLink. Some others said, okay, we can live with higher level, or let's say higher level of cycle times. And yeah, with the frame loss and so on, it's another discussion, I would say. That's again related to the microsecond level and to the very precise how much tolerant an application is to loss of frames. It's let's say a bit of a different discussion. And they said, okay, we can live with something else. So then Profinet RT, Ethernet IP, CC-Link, Industrial Ethernet, they said, okay, we can live with higher level use cases in terms of cycle times. Each of them has created then their own more or less information model. Actually, that's what is known in the industrial automation arena as the field bus wars. And this is what actually we try to solve and to get out of with the new standard independent technologies like the IEEE technologies, TSN, like the 3GPP technologies, 5G, and in the higher layers with the OPC Foundation, with the OPC UA. So basically, I wouldn't say that I would adapt, let's say, I mean, it's possible to live with an information model of a given IC specification and the transport of 5G, if this is feasible. If that consortia, that respective consortia accepts to create a sort of a transfer and the mapping data transfer concept for 5G. If not, it's, I would say, a bit of a dream.
Okay, so I mean, I think you made some good points. So probably I can ask Giovanni also help me here. So actually, you made some strong points that I think we need to clarify because let's say from Huawei perspective, at least, or team perspective, we thought that probably it's better to adopt, let's say, 5G to so-called brownfield technology and try to somehow natively support, let's say, Profinet and EtherCAT and others over 5G as a sort of transport. But from what I'm hearing now is like what you're saying is like probably it's the way that automation world is seeing it is just like, yeah, I mean, so everyone wanted to do something, so they created their own silos. But what if now with OPC on top and probably a 5G or another technology on the underneath, we could just make a sort of unification?
Yes.
So there are two different alternative perspectives. Giovanni or Andre, do you want to pick up on this point? Probably not yet. Okay, so I mean, this is a very good point you made, Marius, because I think.
So we have to think on that. We have to think because if I'm telling you, so in the OPC Foundation, we have a subgroup which is doing OPC mapping to 5G and maybe also some information model for representing some status and so on, some specific status information and so on. So you have a server running, for example, a 5G modem or somewhere in your equipment, if it's an embedded 5G modem, saying what status of the modem, what kind of features does it have, and so on. This is a small, stupid example. Yes, it's most probably it's much more than that. But if you want, for example, that in Profinet or in Ethernet IP, I go because this doesn't Profinet RT, I talk not IRT. And I'm looking to the, let's say, to the network layer and to the transfer layer, to the network data link and physical layer. It's the same like whatever IP-based communication. Then there I can say, okay, I can try a 5G communication because maybe it's like the Wi-Fi and so on. But in the moment that you want to have some 5G related information about status of the 5G equipment represented in terms of information models of those industrial automation specifications, then you need to go to that working group and say, I need to do that, because of course you can do it, but then you'll do it on each project basis.
Correct.
So you will make a Puria project, it will work, it will be verified, and then I don't know, Jose will make his own project, it will work very good, but when Jose and Puria sit together, it doesn't work together, and that's life. And both are right, and it's not that any of you is wrong, but you just decided to represent different information. And about the other ones, like Ethercat, PowerLink, which have a different, let's say, MAC layer, that's not something which is feasible one-to-one. Okay, if you take the Ethernet automation protocol, perhaps, but not the Ethercat, which is used in, for example, an Ethercat slave.
Okay.
So it's a bit of longer discussion here. Thank you.
Just
Thanks.
one quick comment, Puria, if I may.
Sure, please.
I saw, I mean, this Ethercat, Profinet, and all these specialized TCP/IP protocols, procedures in the industry environment are really far for me. That's why maybe question is even silly. But I recall in the past there are some integration works where the Profinet colleagues with 5G colleagues work together to carry the Profinet traffic over 5G. And I don't know, I think similar studies have been done with Ethercat. Marius now really opened up a good discussion point for all of us. Are these really, let's say, some small demonstrations just for showing how 5G can work with others, but cannot really go into the direction of standardization, and it's actually senseless, if I may say, or will not scale up?
Not scale up, I would say. You want to, by scaling up, you understand that if I have a system where I have a device which I call it the middleware, the middleware, what you have there, like the MP3 650 Modbus. So where the middleware is, let's say, Profinet, and in the same network there is another device whose middleware is something else. They don't talk together. They just have different groups, and they. Do you say that it cannot share the same environment? I think it can share. The point is, if you have a device which you have not standardized the way the Profinet is mapped to 5G, or the Ethernet IP or the OPC is mapped to 5G, and somebody else is doing it somewhere else, it might be that these devices will not talk together, right? Because you simply didn't choose the same aspects to cover in your mapping.
I see.
So maybe just to pick up on this very last comment. So first one question. So how it is likely that in one single shop floor we might have some islands of devices talking Profinet, while there is another island of devices that talks Ethercat, and another island of devices that talks another protocol, and then the real need of these islands to talk between each other. I mean, how much this is realistic? Is it happening today? Yeah.
Sure. It happens, and I'll tell you how it is. So it's simply like that. So imagine a PLC or a controller. You have it there somewhere, I think. Yeah, you have several ones, and you see that this PLC has some kind of three pieces there, right? So one of them is the CPU, where you have the processing main processor and so on. I'm not going now on hardware implementation. How is that made? That is 5PGA, it's ASIC, or so on. Let's consider it's a processor there. So it's a processing unit. And then you have communication interfaces. These communication interfaces are correlated with the main processor over very often by each company's in proprietary cabled protocols inside of the box there. And then you have islands of devices talking with the communication interface of Profinet of that PLC. There are islands of devices talking to the communication interface, talking Ethernet IP of that PLC, and so on. So there are, let's say, if you want, it's a sort of physical separation over a gateway or a router. It can be that this has a function of router, really, and you can see one of them. Some of the requirements, some of the use cases do not need a communication from one to another. So, for example, from the Profinet devices to the Ethernet IP devices. And this is what is very common today.
Okay.
What we tried to do with TSN and so on is to unify the MAC layer, the cabled MAC layer, and the physical layer to make sure that all can sit on the same network. You don't need to do this separation anymore. By each communication interfacing, talking something else, even if everything is Ethernet and so on. And with 5G, you want to go even a step farther and say, I don't want even more the cables there.
Okay. I understand.
So
So
that's the.
But then let's put it like I mean let's play the devil's advocate from the let's say the 5G world here. So then with these steps, so now there is a unification on the MAC layer with the help of TSN, and then now with 5G there would be like, okay, we don't want even the cables. Wouldn't it make a huge delay on the uptake of 5G in industrial domain? So make it less interesting for the 5G players to even put efforts to step into this market, at least in a near future. Because another thing that we should not forget is that for 5G to be effective in terms of solutions. So I think we have some other slides that probably I should present to better speak on that, because when we talk about what is the difference between 5G and in industrial switches, like for a switch you just buy a switch, but for 5G you need to buy a system. There is radio part, there's a core part, there is like different elements, and then there are user equipment parts. So there are at least three cycles of technology that needs to be developed, enhanced in a harmonized way in order to reach a goal, like lowering the latency, or I don't know, whatever, this unification. And then the 5G players, if they don't see an uptake potential in an industrial domain, they might not start working on the proper standards for the next releases of these three elements, right? And then if they don't do that in this current release, they are delaying potential of having those solutions at least for a cycle of 3 to 4 years. So because the standard does 1 year and a half a study, does 1 year and a half of let's say a specification, let's say fixing the specification, and then the new releases of devices would come out. So if we don't do these things today, we would not see it in the next at least 4 years. And then if we wait for the uptake in the industry in a way that, okay, let's do the unification of the with the TSN on this, I don't know, period of 2 years, and then with 5G we hope that in the next 5 years we will do that, probably the industry of 5G would drop this, would not work on that, and would would wait for the next 10 years to start working on that. So do you get my point? So it's a chicken and egg problem. Should we start working on that now, or no, we should wait? So I think it's $1 million question in a sense.
No, I think it should have. I mean, it's my personal opinion. So I believe that it should have been started some time ago already. And I think by the 5G ACIA started
exactly.
that actually.
Yeah, exactly. That's also correct. That's also correct.
And it's going more in the direction of OPC Foundation, as far as I understood.
Correct.
Because OPC, the difference between OPC UA and the other field buses, existing field buses, is there are several ones, but one of the important ones is that you can use this notion of object-oriented programming, object-oriented representation for the information modeling, whilst on the other ones you didn't have that. So it was the other field buses is some sort of a, more or less, I don't want to be that rough, but it's more or less of a hardware implementation into software. Let's put it this way. Okay. So it's very often bytecodes and control words and things like that you have to let's say evaluate in order to take an action. Somebody can say, okay, but that's fast. Good, fine. It doesn't take processing power that much. Instead, an object representation is something much more complex. It needs much more power, but we have a bit more different processing power today than what we had in 1980s.
Exactly.
So I believe, yes, you're right. You should be moving much more in the direction of industrial activities, like what we did with TSN, actually, with this TS68, IEEE IEC 6802 TSN for industrial automation profile. So that's what I hoped also the 5G CIA would accomplish.
I mean, of course, exactly. I mean, and I have it in my future slides that 5G CIA is exactly doing this. But as I said, like I think there was this this gap or this question that should we leave completely the brownfield, saying that okay, we would not try to have, let's say, natively support of Profinet. So let's drop this option. And then let's wait for a uniform solution of OPC UA and the others, and then 5G would enter to industrial domain when there is OPC UA already widely implemented. This is a more or less maybe a business question, because the thing is, like, if we natively support Profinet today, probably the adaptation of our technology in the vertical domain would be faster and easier because there is already a huge implementation in place with OPC. But
you will do it both. You'll do it anyway,
yeah,
both in the
I mean,
same
we will
time.
do it both. Yeah, correct. So
because
maybe
maybe you'll create some projects which will not be 100% compatible with other projects.
Exactly.
Because
Definitely.
this is life. You don't
Yeah.
have a full specification to cover all aspects. But
Correct.
you are doing it today. I think we are doing it. We are trying it today.
Exactly. All right. So if there is no further, because I think, I mean, the future slide would also elaborate, I mean, like, would help us to further elaborate on this conversation. So just checking, is there any other comments or question, or is it okay to move next? Okay, look, maybe we move next. So again, I think we almost kind of covered this set of slides. So I just tried to show them quite fast. So basically, yeah, okay. Just for those that did not follow necessarily whatever that we talked about, I try to simplify and quickly recap and see. I mean, basically based on my best understanding, and which is not a complete perspective, but just so again, what we said is, like, you might have a device here, you might have another device here, right? So it could be a PLC, it could be a laptop, whatever. But then in between, you have some so-called intermediate nodes that might be a switch from Cisco or ADVA or I don't know, whatever. Or it could be, I don't know, a cellular technology. It could be a 5G system. And when we are talking about 5G system, basically we are talking about a set of antennas, some user equipment, some control of antennas, and then so-called core network that maybe the best way to put it simple is like to translate the word of 5G into the word of internet that exists around us, right? So, but then again, the main point is like how this information travels from point A to point B, either using those switches or either using this 5G technology, right? So, and that's the main concept, because what we discussed so far with Marius is like, this is the model where an application produces a data, goes into so-called IP packets, travels from device A over some network with some switches and routers and reach to point B, right? So this is a normal, let's say, internet. But then in the industrial domain, because they wanted to reach a faster processing, I don't know, faster processing capacity, or I don't know, reach to a certain type of KPIs, if I may use the word. You can see they made some changes, even in the way that the application would produce a so-called packet and send it over point A to point B. And yeah, here you might have different solutions. So IRT, let's say, yeah, Profinet IRT and so on and so forth. So and this could be interesting for people of 5G, let's say, because what we used to work with normally, because of our traditional client sector, is normal TCP IP model, which is the normal internet, because basically so far we've been serving people using their cell phones to reach out to YouTube, right? So basically it's an IP packet produced here that needs to travel over our system and then reach to the internet. So basically, if you may, you can think that this is just another piece of extension of internet next to your phone, right? So, but then when we go to this vertical domain, we see that, oops, wait. So there are some layers, there are some things that are not necessarily similar to what we are used to. So is there anything that we need to change in our system to support these things? And yes or no? And again, from what I heard from Marius is like, even automation world is a bit tired of this so much diversity, and they are moving towards a sort of unification. And they hope that this wireless communication could help them to better unify things. And this is, I think it's a very, very important point. So because I mean, originally before hearing Marius, I was thinking that probably one of the objectives that we can pursue is basically focusing more on these changes compared to the normal internet protocol stack, and then try to natively support them over 5G. So if you may, from this point A to point B, something can go with this class C type of communication rather than a normal, let's say, IP protocol stack. But I agree with him that we should also not live in an ideal world. So probably what 5G needs to do is like to boost its own business first, also take care of this type of different protocol stacks from one side, and on the other side, try to be the one of the solutions supporting this unification and position itself like these two. I think these are quite important points, and thanks for making them let's say clear for us here in this meeting. So any other comments, questions, doubts? I don't know, Andre, Giovanni, do you want to ask any question?
No, Purya. I think
Okay,
I'm
good.
fine so far. Yeah.
Good,
That's
good.
all for me. No questions so far. Yeah.
Thanks a lot. So any other colleagues, do you want to make any question to, or not? Maybe we can move forward. So yeah, so again, when we talk about like here, probably it is more obvious. So we have this kind of summary of these type of changes compared to let's say normal let's say internet protocol stack, if you want. There are different solutions, yeah, different Ethernet IP, EtherCAT, Profinet, different models of Profinet, Profinet IRT, Profinet RT, NRT. So again, I think it's a $1 million question to see like, okay, does it really worth to put a lot of effort and to support this natively by 5G, or 5G says no, I want to be the technology for the uniform, let's say. I think, yeah. So just to tell you that there is a huge diversity, and another important point for me that I also took from Marius is like, it's very likely that in one single shop floor you would see a diversity of this protocol coexisting, and maybe in some cases they need to talk to one another, and it is quite complex. So I think it's a very important thing. So because in the 5G world, let's say when 5G came, everyone was saying 5G is the network of networks. So it's like a kind of connector of different networks to one single entity. So maybe the same might apply here. So if we think that there's a network of EtherCAT and Profinet, and maybe 5G could be really this glue. I mean, just as an idea, maybe we can think of it.
Purya, maybe I can
Yes,
comment on this slide. So
please.
just to let you guys know that we've been studying the street protocols because they are mostly deployed in the industry, as far as we know. For example, Ethernet IP, we wrote 100% compliant. This means that 5G today can actually support this protocol, since this is 100% compliant with the CPIP. EtherCAT is a different story. Is non-bridge networks, is a loop. It's a kind of loop network. So it's quite difficult to support for 5G, given the 5G is a different kind of network. It's more applicable for typical bridge networks. And then we have Profinet, no real-time Profinet. Yes, I mean 5G can support it today with acyclic communication. Bit different with real-time Profinet, depending on the cyclic communication requirements. When it comes to isochronous, in that sense, it's we need specialized hardware. ISIC, 5G cannot support this kind of applications. And this is a bit of the overview of what we've been studying these days. Thanks.
Okay, thanks for the clarification, Giovanni. Very, very excellent. Thanks a lot. So again, as I said, so our initial let's say point of departure was just like look what exists in the manufacturing sector and try to see if we can natively support it, yes or no, and if yes, what we can do and not. But then probably as a midterm or a bit longer term perspective, we should follow also what Mario said to kind of be the one of the solutions for this uniform, let's say, angle. And I think, yeah, we are and this project is one of the steps towards that goal. So, okay. Again, a bit of more detail about 5G system. So far, is there any question, doubt, comments, points? No? All right. So,
I have one question, Purya.
yes, please.
Is there any intent to already test some of that protocols in this research project, or is this maybe then a further step later?
Oh, that's a very good point. So that's one of the things that I need to check with the trial handbooks myself and see if we are going to check those. I mean, my personal, let's say, preference is like if we do it, then that's excellent. That's perfect. So, but I don't have a yes and no answer, at least at the moment.
I would expect at least for Profinet RT we can try something, maybe also with Ethernet IP. With Ethernet again, 100% adhering to what Giovanni was saying before. I mean, not really the case, but yeah, with the Profinet RT and Ethernet IP, you have to have somehow for example, the drives communicating with the PLC, talking something. So either it's doing OPC-UA, either it's doing Profinet, either it's doing something else. What we want to do is also OPC-UA. So maybe one addition you could have in this slide here to put also the same drawing here. I mean, the same table, also OPC-UA actually. So
I have some slides for OPC-UA in the so I have
okay, so
dedicated slides for
okay, then yeah, because we wanted to concentrate more on OPC-UA than on something else. I mean, of course, if somebody wants to try something else, we have it today, so we can do it. Yeah.
Exactly. So for me, we are still on the sort of departing from the background. So OPC-UA is more in the future slides. So yeah, is there any comments or questions? Should we move?
Yeah, maybe when you have interest, Purya, you should go into the use cases or trials what we have, and
Absolutely.
then review with all if there is a, let's say, interest or possibility.
Definitely. This is what I have in my let's say topest priority list to go deeper. I mean that was one of the points that I was trying to not be apart from the discussion of the trials somehow, but definitely now we have them all let's say crafted. Basically, I will go and read and probably contact all of you one by one. Or I mean, but the good point is like we are in the beginning of the project, so we still have a long way to go. So. For sure.
Yeah, now we are in the phase of work package 2 where we would like to draft the architecture, the functionality, and when we have to decide for such a goal, maybe it's good to consider it
Definitely
in an earlier phase.
Absolutely. Very good point. Absolutely. So if I may just go to, so we heard about 5G ACIA as a community and as a group that is kind of creating a sort of, if I may use this word, a marriage between the mobile cellular communication world and the automation world, let's say. So they have already produced a lot of good materials, but of course there is much more to be done, right? So our team is involved in this, let's say, community. So my colleague Andre is participating. Giovanni is also participating. We have other also colleagues participating. So and we have been rapporteurs of several of these documents. We are also contributing to some chapters. But just to give you some summary of what they did, what it means, so on and so forth. So again, I think there are more experts than me on the call about each of these topics, but just to express my opinion and just maybe helping some other colleagues to understand better. So when we talk about 5G system, basically we are talking about, I already mentioned it, it's not just like one switch that you buy and you just connect the cable and that's it. There is a difference because one 5G system is basically three different elements, three different domains by its own. So you have the user equipment. So by user equipment, the simplest one is your mobile phone in your hand, the one that you put SIM card in and it connects to the system. And the way that they are not calling it a cell phone and they call it a user equipment is that because the standardization body, the reference and standardization body, which is 3GPP, would like to keep this word open for other elements, like a car, like an AGV, which is not necessarily a cell phone, but it could be a holder of a SIM card, right? So then they use the word user equipment. So it's something that the user would hold in its hand or would be in the hand of the user to play with, right? So, but then here you have a word, because you might have different user equipments. It starts from the AR, VR glasses, all the way to the cell phones, all the way to, I don't know, OBUs on the cars or AGVs, so on and so forth. So there is a huge market here, and there are different companies working on it. Yeah, Apple is here. I don't know, like there are several other companies working on this domain. Then you have the radio access network, which is basically the antennas. And I think here in the consortium, we have a good expert with us. I mean, actually several good experts that are experts on the radio access network. We have also an SME that is selling product here. And then, so if there is a need, we can maybe further elaborate more on the radio access network. But just to put it super simple, it's just like the antenna part and the controller that controls the resources of the antenna. These resources could be spectrum, could be scheduling of your traffic on the radio side, so on and so forth. So it's a huge word by itself, right? And then you have the so-called core, which is the expertise of my team, basically. So core is more like a control plane of the whole 5G system, if you want. So all so to put it simple, so when you put a SIM card in your cell phone, how the system knows that you are the customer of Telefonica and not customer of, I don't know, Orange. So these are one of the responsibilities of the core, or all the sessions that needs to be, or the signalings that needs to be done to your phone before you move from one antenna to another, and you don't feel a disruption when you are talking on your phone with your friend, right? So these are the responsibilities of so-called core. And then there is a huge system here that consists of several elements or so-called network functions to carry out these, right? So I don't want to go into details on that, but just to tell you that there are three separate elements that needs to develop to the, let's say, with the different steps in order to deliver a complete 5G system. So it's a bit different from just having a switch and then a next generation of a switch and a next generation of the switch. But in all, what you could expect as industrial player from 5G is a logical, let's say, switch that is connecting one equipment from point A, like a device A, to device B. So for you guys, this should be transparent. It's our responsibility to deliver something good enough to make the life of the end client super easy. So what the end client would see is just like, yeah, I have device A and device B, and I want them to be connected. Okay, I want to do it wirelessly, and then this wireless logical switch is a 5G system. But just to give you a bit of detail about what is going on inside this logical switch, right? Then 5G CIA did some study to see how this 5G system logical switch could be inserted, if you want, into the industrial world. So they came up with different scenarios. So you have actuators, and you have the bridges, which is basically another switch probably, and then the controller. So 5G system could be, from their perspective, between the actuator to the bridge, let's say. In some cases, they claim that it could be between controller and the actuator. So you can see actuator needs to have the user equipments, so a sort of SIM card thing. This could be a so-called CPE. So, or I don't know, you can say it is like imagine if you think of a device that can communicate from one side with 5G and from the other side connects to an actuator, and then the user plane function that talks with the controller. So you can see in between there are antennas. And then there is also, let's say, a model that you have like multiple industrial domains. For example, this is an island of Profinet, this is an island of Ethercat. I'm just like inventing it, right? But then all of them are served with one single 5G installation. And I think this could be also quite interesting, because another question that I forgot to ask from Marius is like, if you have islands of Ethercat, islands of Profinet, islands of other protocols, so does it mean that you have 3 different networks? So I don't think that they might all use one single network, but maybe with 5G, we can use one single network to serve everything. So these are the points that I wanted to highlight. And then another point is like, yeah, the communication that 5G supports today could be on layer 3, so IP layer, so you can do what a router does, or layer 2, so you can do whatever an Ethernet switch does today with 5G. So this is something that 5G supports. So you could have 5G layer 2 network or Ethernet, and you can have 5G layer 3 network or IP. So I think Giovanni also mentioned it quite well in the previous slide. So this is what 5G today with the current releases can support. Not for the particular specific protocols of the industrial domain, but you could have a 5G Ethernet LANs, and then with the routers as a router functionality, let's say. So any questions, doubt? Again, sorry, I mean, I'm not like a full expert of all these systems, but I try to kind of high level summarizing them. Question, doubts, points? No? Okay, let's move on. Then another point that let's say 5G CIA touched upon was kind of, yeah, the point that we discussed here to try to, yes, please. Andre, do you want to say something?
No, but just to say that I sent this TS22104 with requirements, and also you can see requirements in the slide what you showed.
Exactly.
Yeah? So this more
Exactly.
because it's somehow it's combined 5G CA industrial use cases and 3GP TS also adapted the requirements from 5G CA, and then also there are values for basic KPIs in 3GP, but you can see it here also. So yeah, basically it's level of millisecond. Yeah, so millisecond, 1 millisecond, and so on.
Exactly, definitely. So thanks a lot. And as you can see, like basically with 5G, what you can, because also Karim mentioned it quite well, and Andre also mentioned it in another point, is like, so not only a fast packet travel time or so-called latency is a benefit from 5G, or the high bandwidth is only benefit of 5G, but high availability is another thing that you can think of. Support for mobility is another thing that you can think of. So for example, just to put you a real life example to better understand this. So you have your cell phone in your phone, and then instead of using your SIM card data connectivity, you are using your Wi-Fi at home. But as long as you move out, you would lose it, right? So, but then you are still walking on the street, and your data connectivity using your SIM card is still up and running. So why is that? Because 5G supports this seamless mobility for you, right? So then if there are cases in the industrial domain that you really need the support of this seamless mobility, so probably we should think about a solution with 5G. Or if you want a solution that the disruption in the packet delivery is very minimal, because it's a very sensitive case, so probably you need a availability or reliability of the connectivity on these levels. Probably here 5G is a better solution. So these are the summaries that has been proposed here by 5G ICIA, and based on this study item of 3GPP. Another element could be the number of devices that one single setup of 5G could support. So you might have one single setup, as I said here, to support a lot of devices in one location. So probably one single installation of 5G could be enough to serve a huge number of things that you would like to be served in one single factory shop. So these are important points. Again, another point to be discussed, and I think we have also a good number of experts in the project to follow this path, is the ownership of this network. So 5G ACIA has driven basically 4 models. One is like the factory owner, because of because of its own concern. It would like to be the owner of everything in the factory. So yeah, it owns everything. The core network is owned by them. The radio network is owned by them. The user equipment, everything is owned by them. So they are becoming a sort of a small mobile operator of their own. Here there are some drawbacks. Here there are some good things. We are not going to go so much in detail now, but this is so-called the private network or so-called non-public network in 3GPP language. So just to make it simple, just think of a private network. This is something that I privately own. Everything is in my hand. I want to operate it. Of course, it comes with a huge capex and it comes with a huge opex, because not only you need to put a lot of money to install everything, you should also be able to operate it. So this is something to be concerned. The other extreme is that, no, I mean, I have a factory and I want to rent something from a mobile operator, just like us, like humans, right? So like client, like normal clients, people. So we just do a purchase. We do a subscription of the minutes of the call, data rates, and we use the network. So we don't own the network. We just do a subscription. So this model could be used too. Now, the point is, like, if my data traveling over this network is secure or not, these things could be discussed and there are solutions for that. But you would not own the network. So the core network, the RAN controller, the RAN devices, everything might not be necessarily yours, but the data that is traveling over the network might be something that we can try to kind of make it private if you want. So it's like, I have a network and this network is using internet, but can I have a private connection to my office in Sweden? And the answer is probably yes, because you could have a VPN, right? So my data traveling from my computer over the public network of internet still is privately reaching to my office because I'm using VPN and I'm not owning the internet. So there are solutions to be explored here too. So it's not just like fully private solution is better than the fully non-private solution or public solution if you want. So these things should be discussed, because what is important, what is not important, how it's important, this should be detailed like any other decisions that we so far discussed in the other slides. And of course, let's say 5G ACIA came up with two other models, which are hybrid models. So you might have shared RAN and some part of the core network also in your hand, like the subscription, or I don't know. You can see on this, let's say table how they made this hybrid private public network. So there might be some companies that they would like to have some control of the network that they install in their facility. So they may make different decisions. Of course, this may vary, the capex and opex, based on this decision. But just to put some light on this definition of public network, private network, why is that better? Why is this better? So it's again another big chicken and egg problem. Any comments? Any let's say
Here,
points? Yes, please.
maybe just to contribute, Puriya, I think you
Please.
perfectly summarized here, especially these deployment models in the trial handbook for the central node trial 2. We also touched upon these different deployment models. I think there is none of these models are the best. There is no one fits all model.
Exactly.
It really comes with its own trade-off points, its own pros and cons, depending on the availability of the company with regards to IT resources, the capex preferences, opex preferences, and the data security, privacy, and many aspects, many dimensions. The enterprises should evaluate which network fits best for them. And one important aspect also to keep in mind, I mean, the slides already summarized perfectly, but just to create awareness, there are two types of traffics running through the enterprise networks. One is the control-related traffic, that is basically to make sure that the traffic is flowing, the protocols and procedures are working as expected, as defined by the standards. It's a 3GPP or some side standards out of 3GPP. And these are basically called control plane traffic. And there is also another type of traffic called user plane traffic. I think in the coming sessions, we will come along with this kind of talks, especially in the 5G context. That's why I wanted to make these two things also aware for all of us. If we talk about user plane, it's basically the data that is being produced by the enterprise and that is being used by the enterprise to further process maybe some
Definitely.
analytics to be done, maybe some dashboards to be created, or maybe this is their proprietary process-related information, highly confidential. And there, these hybrid models, especially the ones in the middle, like putting the user plane function of the 5G, which basically takes care of the user plane traffic through the PDN or towards the intranet, like the operational technology applications, or let's say a more specific manufacturing execution system, let's say in the manufacturing environment, is the actually traffic that still can be held in on-prem, can be piped within the factory, nothing leaves out, but still we can leverage different deployment models. And this is one thing. I think this deployment model is really something in the trials we might even consider to split some network and put some pros and cons, at least to create this awareness for the manufacturers of future to identify what actually fits best for me based on my need. And on the capabilities of 5G side, there is also one very important aspect to be mentioned is the positioning. I think 5G ACA colleagues also touch on this. 3GPP also works a lot on this,
Correct.
starting from release 16 and onwards, it's continuously evolving. Now it's below 30 centimeter with the specs, but with the market, I think we don't find really that precise positioning solutions yet. Pure 3GPP I'm talking, there are of course some side technologies that can improve the positioning skills. And this is actually also making 5G quite interesting for this kind of mobile and large footprint use cases. And one last comment, not to take too much time, the seamless mobility, I think you also touched on this very well. The seamless mobility, just to create this, to visualize what we mean with this is like if there is a large footprint, the device is moving. Maybe the PLC environment is not the perfect example, but AGV is actually one good example.
Definitely, Karim. Perfect. I mean, thanks a lot for sorry, we lost you.
Yeah, can you hear me now?
Yeah, please.
Okay, sorry. So this seamless mobility topic, if there is a large footprint and there is a device that needs to move seamlessly in terms of data communication skills and reliability, availability, and accessibility aspects, there actually, I mean, Wi-Fi is also trying hard to bring some solutions, but the cellular technologies, 5G and beyond, is the only one that is seamlessly addressing this seamless mobility needs to have zero interruption time on the user plane traffic and really like high grade reliability and availability on the control plane traffic, which makes it really important for the manufacturers to know what technology fits best when it comes to reliability. A simple example, if we are talking about Wi-Fi versus 5G, just an example, with this seamless mobility skills of 5G, manufacturer can simply save, I don't know, maybe 10 up to 20% of number of AGVs, just because the handover times are really like close to zero interruption time. The mobilities are seamless, and the footprints are becoming larger and larger, and 5G becoming more and more sensible in comparison to other cabled or Wi-Fi like technologies.
I think you touched upon a very good points because the reason that I just tried to point out this let's say angle of 5G here is that so let's put it quite simple in few bullets. One thing is like the first bullet is like 5G is not one single hammer for all needles, so this is clear. Then second, there are a family of wired technology and a family of wireless technology. So this is the second important thing. So we are going towards the wireless technology because we see benefits on that. So now in the wireless world, if you only focus on the sending data over the medium of air, if I may use this word, or spectrum, then you have the big family of Wi-Fi technologies and cellular technologies, which are those that are working with SIM card, right? So again, there are two big families, and each of these families are also doing releases. So of course, as Karim mentioned, Wi-Fi is also trying to improve on let's say, this seamless mobility, but so far this is not the case. They are targeting in the new releases of Wi-Fi 6 and Wi-Fi 7, they try to, but so far this is not the case. But so again, depend on the use case, depend on the need, or let's say KPIs that you want a system delivered to you. Probably 5G is a solution to be picked, yes or no. This is a decision that the manufacturing sector should take with eyes open. And also, when we talk about 5G, this is a complex system of its own, because then you need to, because in Wi-Fi, you just put a Wi-Fi router, you connect it, and it's easy. You can do it even in your home, right? So setting up a Wi-Fi node is not super rocket science, right? So it's easy to set up, let's say. I mean, just to simplify things, right? But for a system of 5G, it's much more complex. You need to get the devices, you need to have the antennas, you need to have the user equipment. So at least you need to get in. I mean, I'm not saying that this is difficult, but at least you need to get engaged with the 3 or 4 different domains of technology. But then again, this decision should be taken considering the financial capacities, operational capacities, the needs that the system should deliver, and parameters like that. So again, we are just like putting light on that and just making it clear for everyone to have at least a better view on this type of this. Is there any comment, please?
Yeah, Korea. It's Matteo here.
Hi, Matteo.
Thank you very much. Thank for you to cover everything, and also thank to Karim, because I think you both together covered every single point. Just if I can back up on the part of operational costs and, let's say, capex, opex, so the total cost of ownership, and also the difficulties of operating this network. In general, for my experience, is not always true that a private network is more expensive than having, for instance, DAS from an operator. Sometimes operators can be really expensive, can ask for a lot of money. So, but it's difficult to compare because are two completely different business models, and also they leverage on two different ecosystems of vendors, of solutions, and so on. So it's difficult. Are two different worlds, and in a couple of deployments for us, it has been more expensive to put one single slice for an operator than having the whole NPN network, because operators, they apply certain policies for pricing that are sometimes really quite crazy. So this is, let's say, more from the capex side. From the operational perspective, it's true that operating a private 5G network, in general, cellular network, is not as easy as Wi-Fi, but there are tools out there to, let's say, not having, let's say, a zero-touch deployment and operation, but almost. So a lot of operations are, let's say, automated.
Yeah, exactly.
In a few clicks. So even people.
And I think this should be one of the goals for our project, also to push forward, because if we don't have these zero-touch, let's say, operational tools, the NPN option would not be really take up. So just to put it as an option in the market for the players to be able to choose, one of the enablers is this zero-touch management solutions, if you want. So I think this is a very important point you are touching upon. Yeah.
Yeah, absolutely, absolutely. And also for the part of the integration, it is true that if integration with 5G is not integration between, let's say, 5G and the OTE protocols is not still, let's say, I would say that it's still quite at 0 point, because there are some shortcut like using VXLAN to overcome certain difficulties. It is also true that operating 5G inside a factory with other protocols, it might be even trickier than operating 5G, let's say, for the mere connectivity. So in this sense as well, this project, I think, will provide a lot of tools that then the OT can use to really see 5G private or in a very transparent way, as it is a cable, and the objective, in my opinion, should be that it should be agnostic to actually the type of protocol that you are using, if it's 5G, 4G, or whatever, as long as it matches the requirements of the connectivity. The OT department should be, let's say, really almost unaware of that.
Yeah, exactly. I agree with that, because after all, as I said, this is like the final customer, and we should not make their life busy with just learning a new domain of technology and being able to serve it. Here we are just raising the awareness, just to tell them that, look, although you just buy this package, but this package is coming with a lot of system inside. There are a lot of decisions to be made, and you should make a better, I would use this word, educated choice. So this is the whole, let's say, intention of this type of a slide, because after all, what we would deliver all of us as a final solution, ideally, would be just a complete automated system that works perfectly fine. It's a logical switch, and we just tell them that you just connect this cable here, you just press this button, and it works. So yeah, but let's say I'm going a bit more in detail in these slides to just put some light on the dark corners of 5G. Let's see. Is there any comment here? Because yeah, there are more slides to go.
Hi, Corey. Just Stephen here.
Yes, please.
Just two comments on the slide. In terms of the type of network you might want to deploy, access to spectrum is also key, and spectrum allocations throughout the world, and including in Europe, are very diverse. So if you will be restricted, these are all in spectrum that is controlled by government or at least regulators. So it's a licensed spectrum, and individual regulators will have licensed different spectrum. Now, whether you'll get equipment available in that spectrum is not clear. So some regulators in Europe have licensed millimeter wave spectrum for use in private networks. As of today, there's no equipment available that you can use in that spectrum.
Excellent point. Yeah.
So,
actually, here I have a question.
Comes in as a kind of consideration when you're deciding what to do in terms of deploying a network. The other point, just on positioning, and you mentioned in your first slide that the focus initially has been on getting 5G to people. Positioning is not so important for people, it's more important for devices.
Exactly.
And certainly indoors. And with releases, there are certain features that are mandatory and there are certain things that are optional. And all of the optional, or all of the positioning techniques in 5G at the moment are optional. So there are things like LPP and NPPRA and that speak to positioning, and positioning is very important out indoors because, which is typically a factory deployment. Outdoors you can use GPS or to get your location. Indoors you need to use some other mechanism, and the type of accuracy that is in that table is not possible today. It will be theoretically possible in release 17, 18, but again, almost certainly the aspects of the standards that touch on positioning, they might or might not be implemented. And for this type of positioning that you mentioned here, it needs support from all of the devices that you talked about. So the UE has to support it. The base stations, the RAN has to support it, and the core network has to support it.
Definitely.
And unless all three devices support it, you're not going to get the type of accuracy you're talking about. So I don't think today you're going to see sub-meter accuracy indoors without using something over the top, some camera assistance or some other type of technique to find your location.
Absolutely. Very good point. Thanks a lot, Stefan. I mean, super nice points. I totally agree. I mean, yeah, definitely. I agree. And but again, I think because one of the other angles that a project like us can do is like to be a vehicle to rise or voice and demand basically the need from one side for the future, let's say, free spectrum if there is a need for it, because so far state members, at least in Europe, they are not completely realizing, all of them are not realizing the need of reserving some part of spectrum for so-called NPN. So this is not becoming, let's say, evident for all of them. So there are, I mean, there is this huge diversity. So probably if we can provide an argument on that, and if we can craft it in a nice way and try to promote it in our events or things, I mean, if we believe that this could be a way to go, so project could be used as a tool for that. So it was one of the objective of the project too. So this is number one. And then technically as well, I agree with you that the positioning basically so-called has been treated a bit more like a luxury. But again, if it's needed for this particular sector or vertical domain, maybe we can also try to promote it more and more and try to see if it becomes a part of the package as a mandatory option and not just necessarily as an option. But then this will come with the huge future delays, basically. So is there any point, because I think I will come back to this type of positioning and things in the future slides too. So I mean, we maybe we can continue that there.
Sorry, Puria.
Yes, please.
Because I have a question, let's say, related to the spectrum, and is more also for all the audience, because during the Smart City Expo yesterday, I assisted to a speech of the UK TIN, the Telecom Innovation Network, and they said, and there were also people from Nokia confirming that, they said that at the European level, so the European Union is having an agreement of harmonizing spectrum on the upper part of N77 for private network, starting from Q1 2023. So it seems that is imminent, but honestly, I didn't find any other confirmation apart from what the UK government and Nokia said during that. That I don't know if anyone here is aware of that.
Personally, I'm not, but others, have you heard of this?
I can try and verify. We have people in Acceleron who are in UONA. Yeah, the trouble with that spectrum at the moment is that there are no commercial devices that operate it. So it kicks any use of it down the road by a couple of years. There are some CPUs, as you mentioned, Puri, that are coming on stream that can operate in that spectrum in what's called standalone mode. They can operate in that spectrum in what's called non-standalone. It's a bit, I won't go into it, but that can operate in standalone in that band. There's nothing available today in millimeter wave.
Okay.
Thanks.
But one point,
yes,
maybe
please.
not related to that, what I don't see it here on this drawing, but maybe it's somewhere else, some hidden somewhere maybe. It's also the notion of resource reservation, or let's say the notion of competing for resources, because you may have lots of devices and they want to use the resources, and they have to know, for example, when they have to communicate in order to make sure that you deliver and you reach the deadlines. So maybe you have somewhere else this aspect that I don't see it here on this.
Okay, I understand your point. I think probably I have it somewhere. So it's more like time-sensitive networking and scheduling.
Like quality of service requirement. Yeah, so I'm requiring them this application, requiring
exactly.
this, and so on.
I have it in another slide. Yes.
Okay, thank you.
I do. Yeah, that's also very important. I think it would be one of the topics that we really need to dig deeper. Yeah, definitely. So if I may just go to, so is
just
there
one thing?
Yes, please.
Just one thing, Puria. Sorry, this is the last thing. Then I shut up and I let you go. Otherwise, you're going to throw me something. Related to the comment that you made, very very useful and really on time. Related to, let's say, sensibilization of the policymakers and the decision maker regarding to spectral harmonization. There is an organization called EUWINA. Then we can type it in the chat, in which Neutron and Opticoms are already member. That is actually the objective for EUWINA, is to sensibilize the policymaker, the European and world level, about the existence of MPN, the necessity of harmonizing the spectrum, and so on and so forth. So
I just posted, Matteo, sorry to interrupt.
Thanks, Karim. Excellent.
Some minutes ago I posted, and coincidence now you touched. Perfect. Thanks a lot.
Thanks a lot. Thanks to you. Okay, so I would invite all the people here to have a look to EUWINA, to decide to join, because I think the more we are, the more weight we can have on the policymakers.
Oh, that's excellent. That's excellent. Thanks a lot for sharing this this information. I mean, it's quite important and quite nice, because let's see in the future steps of the project, even how we can collectively support this. So I will think about a way. I don't know, maybe send some, let's say, I don't know, I would not say result, but maybe a kind of official thing from the project to this body to yeah, but I will think of a way to see how we can support. But now the fact that you guys are present there and then others are also invited to join, I think we also could say that we as a group, we are contributing to promote to this NPN. Thanks a lot for sharing this. So I would just quickly move to and because yeah, I mean, I think we are also a bit like running out of the time, so there are still a lot of things to be mentioned. So yeah, okay. So again, example of what has been done so far and what has been supported so far. So I think we touched upon a lot of these things here and there, but again, 5G ACIA has proposed a lot of things and many of them has been standardized so far. So support for highly reliable communication is one thing, providing quality service mapping between time-sensitive network traffics and the 5G QoS, quality of service flows, is another thing. So probably it's very it's more or less something that is close to what Marius just mentioned. I have another slide for that I go a bit deeper. I think we can dig deeper and further down elaborate on this. But yeah, there is a mapping between time-sensitive networking traffic and then 5G QoS, because there are two different concepts and they need to map to one another. Deployment of, let's say, reference point for the exposure purposes and access to the upper layers. I think this has came up also in this conversation so far. So there are solutions for that, there are suggestions for that, but for sure these are not the ultimate ones, and still there is a huge work to be done. I remember a while ago we've been talking about, let's say, time synchronization and all of this, and yes, I mean, this is something that 5G, beside the other things that it offers, could offer a reference time synchronization for you. So again, there are some solutions for it, there are some suggestions for this, for 3GPP network, for non-3GPP network, but then yet probably we can have a look, and if there is a need, we can further dig deeper and try to elaborate more. I think, yeah, so again, for the time synchronization, time-sensitive network synchronization and the support of IEEE 802.1as over 5G and introduction of this, let's say, translator between the IEEE world and 5G world, this has been done also so far, and it has been supported by 3GPP. But just to tell you that there is a huge, let's say, steps already taken, but there is a word that is empty. We need to dig deeper. So just again, I think so far also we have been discussing a lot about what 5G can offer, what type of, let's say, use cases for industrial domain can be supported. So just let me probably express this, let's say, a slide in a, let's say, as much as simple as possible. So the 5G world, to begin their understanding of how I can support people and things with the help of ITU, which is a reference organization at the level of United Nations. So it covers, let's say, all nations in the world. They came up with a sort of triangle that would emphasize on different aspects of this so-called 5G system. So one angle is enhanced mobile broadband, so receiving more and more data rates, bit rates, or bandwidth over the devices. So if I'm receiving 10, I should be able to receive 1,000 now. So the focus here is not necessarily reaching to my device as fast as possible, but this angle promotes mainly that the more bandwidth, the broadband service that comes to my system. So, but at the same time, they said that, okay, yeah, there might be some services that they just need a fast communication and might not necessarily need a broadband connectivity. So in the other angle, they put the ultra low latency and ultra reliable communication. So here, in this side of a spectrum, basically, or this side of, let's say, this on this vertex, the more emphasis is on reaching as fast as possible to the device and create a low latency end-to-end. And in the another angle, they said the network should cover a massive number of devices. This might not be necessarily high bandwidth. This might not necessarily be let's say, lower latency type of communication. But here the main focus is the massive number of devices, a huge number of extra devices that can be connected to one single network. And with this landscape, they kind of designed this triangle for 5G. So if I have a use case, autonomous driving, this might stand somewhere here because it needs a good, let's say, coverage of ultra low latency, and it needs a bit of, let's say, a certain point of the broadband width compared to what 5G nominally can deliver. And maybe this is not necessarily a point of, let's say, massive machine type communication. So then in the 5G world, it became a tradition to figure out the need of each use case and try to position it in this triangle. And this is what 5G ACIA did, at least for some of the use cases. So you can really see it here. For motion control, they do believe that what is more important is to provide a lower latency rather than providing a high bandwidth or providing a massive number of devices that can connect to the network. The same goes for mobile control planes with safety functionality or mobile robots. So they started checking what is going to be the case inside the factory shop floor and try to position them in this kind of triangle. And I don't know, just another example, augmented reality. So you might have a glass in your head and you want to do predictive maintenance inside the factory. So probably here, what is matter, because there is a huge content of media that needs to reach to your headset and it needs to go back, probably having a broadband connectivity is more important than necessarily having a extreme low latency. So they try to kind of classify, and I found it quite interesting. So I was like thinking that probably for our trials, at least, we can do the same practice and we could figure out that where these things could sit in this triangle, if I may use this word. So another example is this massive wireless sensor network. So because even the word says massive, then probably the 5G could help, but on this massive machine type communication. And this deployment of 5G might not necessarily be ultra reliable or ultra, let's say, lower latency, or might not provide necessarily huge bandwidth, but it is still providing a massive connectivity over one single network. So is there any question, doubts on that? Do you agree with this type of classification or an attempt toward this in our project?
Yeah, may I comment?
Yes, please.
Yeah, so I agree with with the classification and the use cases and so on, but I think that I don't know, probably I'm too pragmatic, but we should manage the expectations, because I think that would be good to select some of the use cases that we support, what kind of use cases we deploy or demonstrate in the project, but then we need to be quite understanding what can we deliver out of
Correct.
this, because I mean, I know that TSN is there and there's a bit of hype and there's a huge set of expectations, but I mean, in practical terms, we need to understand what can be deployed and delivered on these use cases with the existing technology or the technology that might become available during the project lifetime.
Correct.
I'm saying because, I mean, we have been working on TSN for more than almost 3 years in another project, and the outcome of that is far from what is expected in the TSN. So the thing is that in the standards we define a bit of high expectations, what the technology can bring, and that's fine because that's the target. But then from project point of view, I think that we should be a bit of realistic and seeing that, okay, this is the long-term type of use cases that we want to deploy, these are the requirements and so on. And then in the meantime, we need to understand, okay, out of this use case, what the technology can be demonstrated or validated within this time frame.
Absolutely. Totally agree with you. Yeah, definitely. I mean, yeah, I mean, I completely agree. So we should not be over-promising, basically. Yeah, definitely. No, completely agree.
Puriya, if I may comment very short.
Yes, please.
The triangle of 5G, let's say with 3 different services offered by 5G, just to emphasize, can be also combined in under one 5G solution. And that is exactly this network slicing concept. This is basically managing the quality of service. Let's talk about the physical infrastructure. We have limited resources in terms of processing, storage, and RAM capabilities that are all the infrastructure hosting 5G softwares on top. And as much as the infrastructure allows us, we can still like combine different services into one environment. And with different quality of service management profiles and slicing options and other mechanisms, we can offer these 3 in combination depending on the use case.
Definitely.
So it's quite normal if we fall into a use case which requires a bit of this, more of this, and mostly this. This is actually, it's not like either this or this or this.
Exactly. So, I mean, I think I have another slide later on that could help us better understand this, but you're completely correct. So I'm not referring to for having a broadband service, you need to do a one single deployment, and then to have a lower latency, you need to do another set of physical deployment. No. But then these are different types of services that can be tuned, basically, and you can have a use case that is enjoying, let's say, here a point of, let's say, type of service, while another use case on the same infrastructure enjoying another portion of the let's say service characteristics, if I may use this word. Yeah, perfect. So let's speed up a bit because I have some more slides to say. I think we are still running out of time. So
Yeah.
here, yes, please.
Yeah, this is George. I think I have reserved the link for 1 more hour, so
Yeah,
we
exactly.
have time.
That's why
Yeah.
I need to speed. No, I have more slides to talk about. So and I did not reach to the main point of the conversation. Is yeah. So I mean, we have 1 hour and a lot of points to cover. So this slide is coming from OPCUA, and they had a webinar recently with 5G ACIA. So this has been taken from that webinar that is publicly available. I think I shared the link over the community, but I invite everyone to also have a look. Of course, there are people that already know this better than me, but yeah, I mean, just try to summarize and try to express at least my perspective on that together, and we can see. So one of the things that as we saw by the wonderful comment from Marius is like this sense of unification is happening, right? So OPCUA is this attempt. Sorry if I'm not referring it well, but this is basically my understanding of this word. And then one of the items that OPCUA also claims is this wireless integration, in parentheses 5G, and it's here, right? So then the type of 5G is basically this 5G URLLC system, so ultra reliable and low latency. So if I may use, so they're talking mainly about this part of this angle, and they think that this is the more interesting part for the potential use cases. Probably it makes sense because at the moment, let's say use of augmented reality in the manufacturing or maybe other parts are not necessarily well adopted. I don't know. I'm just like making my guess. So for some reason, they just focus on this 5G URLLC. So here we have a sort of 5G connectivity that can be ultra reliable, so you would not lose packets easily. And this provides also a low latency. And then they are using it for this, reliable streaming of data and events and cyclic process data exchanges. So these are the things that they showcased or kind of put emphasis on this presentation at least. So again, sorry if I'm not the super expert, but I'm trying. So for the OPCUA, the way that at least I understand, and please correct me if I'm wrong, this is the position that I see where 5G and OPCUA world might interface between one another. So as far as I understood, OPCUA is a model of let's say, it has a model of, let's say, server client data exchange, if I may use this word. And then there is like of course, there is a network in between that needs to connect this server and client to one another. And then there is this OPC UA FX connection or POP-SOP that makes this type of connection possible using a cellular connectivity like 5G. Yes, please.
Okay, so let's a bit eliminate a little bit some confusion here.
Okay.
So OPC brings in mechanisms which you have there on the left-hand side, which are pub/sub mechanisms, publisher-subscriber mechanisms, or client-server. If OPC field exchange, so the yellow part, what you have there in on the left-hand side, is brings some additions to the existing models, some completions that is bringing OPC also in the field level. You are showing the previous slide on that. So there, FX is also shown reaching the field level, because up till now the OPC UA was very much common into what you call the vertical communications. Yeah, what you have more on the left-hand side of the drawing, so the number 1 arrow there.
Yeah, number 1.
And yeah, then we try to bring in, some bases were done for number 4, and then we want to bring in number 5 and 6 by the field exchange. If that is based on publisher-subscriber, it means that we just started with publisher-subscriber. It doesn't mean that it's only publisher-subscriber.
Oh, okay, understood.
So it's publisher-subscriber is a set of specifications. It's part 14, or 10,014 or something like that. How is it called now? Which is a OPC main working group realization. OPC FX is creating the notion of connections. The notion of connections is bidirectional. In pub/sub, you had only one unidirectional connection there. In FX, you need to have, let's say, a dual channel, if you can say like that. So you have, let's say, request and response in the same connection mechanism, because you need to have also some keep alive mechanisms and all sorts of things which were missing in the OPC base pub/sub specification. Therefore, the OPC connection is formed of 2 pub/sub connections, if I can call it like that, one in one direction, the other in the other direction.
Okay, I understood. But maybe for again, this is, sorry for my ignorance. So because the way that I understood OPC UA is that, how can I put it? Let's put it in a very simple example to better express myself. So if I think of one computer connecting over a network to another computer, for me, OPC UA in this scenario stands on the level of a web browser. So it's a web browser inside the computer that is connected to another cable to another computer. So no? So I'm wrong. Yeah.
No, so it's more than the web browser. Is also, if you want, the web server. It's more the web server and the web browser. The web browser is the OPC UA client.
Okay.
The web server, okay, you have another computer. Let's take it simplistically now. You have one computer with a web browser and one computer with a web server. Okay, you will say that it's somewhere in the net, in the cloud, in the internet. It's true. But let's take it for the sake of the discussion now to make it simple. So the OPC UA server is very similar to the web server. In the web server, when you create the web server, you have some HTML or XML or I don't know what. You have some kind of JavaScripts there. You have quite a few things in order to specify an information model for something. I don't know. You want to have the information model of a 5G modem, for example. You sell 5G modems and you want to have nice information about that 5G modem, which some web server can read. So this is, let's say, the web server is the OPC UA server, and the web browser is the OPC UA client.
Client, okay. Yeah, I understand. But then again, it doesn't come to the level of the let's say so imagine in the same example of the computer. So after all, when I do when I want to reach from my web browser to web server, after all, the data will come to a network card and the network card were translated to some IP packet, and this IP packet would be traveling over the network or the internet to reach to the. So OPC-UA so far is not reaching to that down level of touching upon the transport, if I may use this word.
Yes and no. Yes and no. So for okay, so for the client server communication, no.
Okay.
For the publisher subscriber, yes.
Okay.
Because there is defined this notion of network message, and we were discussing that in some other email and so on. So the notion of the network message is a sort of an improvement or a specification of the UDP. So it's an addition in the payload for the UDP datagram, which is called UADP.
Okay.
So that is defined also in the OPC-UA specifications. What is also defined in the OPC-UA specifications is how to map, and you have it already there on blue, and that's why it's on the blue color. Use case specific mappings to protocols and physical layers.
Correct.
For example, we talked already about the first of two, but you have also direct layer 2 mapping, and you have a mapping of MQTT. So you can do OPC-UA mapped over MQTT, for example, exactly for that use case which you have in the middle on the right-hand side drawing. So it's the sort of an equipment trying to communicate somewhere with the cloud. So for example, the controller has an OPC-UA server and wants to communicate with the cloud, and it's communicating over OPC-UA over MQTT. This is one mechanism.
Correct.
This means PubSub, you can have a broker-based architecture or a brokerless. If you talk the UADP mechanisms with network messages and all these things, this is brokerless. If you want a broker-based mechanism for PubSub, then you're using MQTT.
Okay.
So that then OPC-UA is mapped to that one. So there you have this kind of mappings. So it goes a little bit to this kind of layer, and therefore you have it on the blue color on the left-hand side. Now, what with OPC-UA fix do we want to do, and with other specification of OPC-UA is, for example, we are trying, for example, base network model. We are trying to specify also the quality of service needs of a end device. We kind of specify also the capabilities of an end device, what kind of cycle times can it support, and so on.
Okay.
So some kind of client or subscriber, if you want, can read this kind of information if somebody is publishing them, a server or a publisher.
But probably, I think now, we also got to a quite an important point. So if you may just like list this quality of service, if I may use this word, and then coming back to the previous point that you mentioned about the unification, and then how TSN became handy in order to unify, and then probably the next step is to 5G. Then my question would be, this list of a specification, how much it could be mapped directly to 5G QI, or is there any necessarily a need to go through TSN and then 5G? Because if sorry, just to in parentheses, so if we go like TSN and then 5G, many of the 5G people would already claim that, oh yeah, but 5G already supports TSN, so whatever development TSN does, we just change the translator and then it's supported. So
no, the connection is somewhere else. I understand very much your concern.
Yes.
It's imagine that you have exactly that stacks view, what you have on the left-hand side there, also for Profinet, and you have it also for Ethernet IP. And all of that finds itself in controller number one. Controller number one is a smart device. We can talk everything, right?
Yeah.
So it has several stacks in it and so on, can talk with different devices, different languages, yeah? The point is on network management here. So who is actually configuring the network interface? So the OPC-UA server can publish and say, hey, this is what I can do. But if you want to support unification, also between industrial automation specifications or stacks living in different equipment or in the same equipment in a network, you cannot allow only one of them to decide on the utilization of the network interface and the configuration of the network interface in terms of network resources utilization. So you need to request to discuss with the network controller and say, hey, this is me, the application one, which is running in an OPC server and wants to talk each 10 milliseconds with a frame which is having a total size of a total payload of 85 or 100 kilobytes. This is what I am. And then there is another application number 2 who wants to do something similar. And the network controller gets all that information and says, okay, what kind of mechanism do we have here? Do we have here some kind of a wired communication? Okay, this who is in the wired communication? There are some network bridges and so on. How should I configure them to allow this kind of requirements? Okay, there are not network wires. This is some kind of a bigger story. I want to communicate with something much more distant over a 5G interface. Then I need to make sure, and we come back to the other discussion, that I require the necessary resources over that network so that my communication is allowed. So I need to have a mechanism in place to do, let's say, smart network management, if I can call it like that.
But then a smart network management, is it coming to the level of the automation platform sort of? Because again, I think here there is a word that could be misunderstood by the telecom people, because when we talk about network management, basically, I'm sure most of the telco people would think about a model like Etsimano and OSM, and I don't know, this type of, let's say, automation in the management of network resources. I don't know, like these resources could be computational resources or spectrum resources or so on and so forth. But from what you are mentioning, if I'm not wrong, please correct me. So, because I remember and I don't know if we have Artur here also, but probably he could also help. Because I remember in the showcase that they did in 5G ACIA, it was like this device, the controller, and was represented over this platform of IEC platform. Then there was like a representation of this connectivity and then the other device on the other side. So probably this request and ping pong that we are talking about should happen between this automation platform and devices, right? Or you are referring to a sort of Etsimano perspective of the word, which is probably locked into the ICT domain.
I'm not aware of that, the one which you mentioned. I can tell you how it could work. I can tell you how it could work. So you have the level of the industrial automation island. In the industrial automation island, you need to have a sort of a controller, network controller, to allow local communication. If more than local communication is required, that controller needs to talk to another controller somewhere in the 5G network, I don't know where, which knows some other controllers too.
Exactly.
And talks and knows and tells them, yeah, I understand that you want it, but it's not possible. Or yes, I understand it's what you wanted, and it is possible, and you need to have that configuration. And then the local controller understands that, says, okay, I have to have that configuration. I understand. Okay, then I need to have to think now to tell to all my devices when to talk and how, so that this can happen locally.
Understood. I think this is another point for at least for us, like people coming from 3GPP, to keep in mind that when you're saying the network management, you are not necessarily referring to Etsimano. So that's a very good point, because I think this would be like a sub-controller under a bigger controller, if you want. So okay, it's a very good. Yeah, I agree with you, and I think but just to clarify that for people to not get confused between the same word of network controller in two words, let's say. But very good. Thank you very much for this interesting point. I think we should for sure dig deeper on that, and these are very important points, because as we were discussing, I think for sure there is a need for exposure of resources as 5JCIS also started, but I think we should dig deeper. Again, this part that we have mentioned about like requesting things and then how to map it in the queue quality of service in 5G. I have a slide for that too. So there is a lot of fronts to touch upon. I just want to check with I don't know, Andre and Giovanni. Do you have any other further question here, or we should move? I think we need a dedicated session for just OPCUA and 5G.
Yeah, I agree.
Yeah, I think, I mean, with a very quick thing, we cannot touch upon all the aspects. But okay, let's keep it open for the moment.
From the automation point of view, you would like to ask.
Oh yeah,
I
yeah,
can
absolutely.
give you the
Perfect.
following
I thought
feedback
you're
for
out.
that.
Yeah. So
But
I was thinking about this automation platform that here
yeah,
they're talking about is probably this IEC
4099.
Exactly.
Yeah.
And
So
then
this is a standard
Mhm.
for designing distributed systems. So
Okay.
normally you have one unique engineering environment where you design a distributed system of multiple controllers, and you design the communication between the controllers. So it is normally over TCP and UDP.
Okay.
So this is a protocol of the 4099 standard, where is also conformance profile available. And on the other side, you also design the file bus interfaces, what we have to discuss today. And you also design, let's say, the communication to the upper layers. In that case, maybe to a virtual edge, what we have in mind here, or a cloud, where we would like to communicate over OPCUA, for instance. And for all of these protocols, you normally design this network relation, and you can also define the network parameters for the protocols, like the IP address, the port, or some others. And
Okay.
normally, when this is integrated, we also configure OPCUA stack. Yeah, it depends if the automation platform is an OPCUA client or if it is an OPCUA server. Publish subscribe actually is, from OPCUA point of view, not integrated right now. MQTT, we have some prototypes met for publish subscribe. So, and this is all the possibility to integrate somewhere this configuration stuff into this engineering tool for the automation platform.
Okay, I understand.
And maybe from the runtime point of view, I have only one question. I'm not sure if one of you can answer that. Is we have actually an OPCUA stack integrated from Unified Automation. What do we have to do that we can communicate over 5G? Is there something special we need, or should this be transparent from that point of view when we have this stack integrated, this software stack?
Do you need, just a quick reaction, Arthur, do you need to have a given quality of service, or you don't care, it's just the best effort?
How do you mean this?
I mean, quality of service. I mean, for
I
example,
have a
there
slide
is
for that.
noise. There
You
is
have a
noise
slide?
in the network. I don't know.
I have a slide for that. So if you
Oh, you
wait,
have a
maybe
slide.
we
Okay,
go
thank you.
and come back to this question on the slide, because I think Marius put a very good point here.
Okay.
Or if you want, maybe I can just jump quickly there to, I think it's just like few slides away from here. Okay. So when we're talking about quality of service on the 5G world, is basically this one. Yeah. So basically, let me point it out like this. So imagine I have an application here. Okay, this could be whatsoever application. It could be Skype, it could be YouTube, Netflix, whatever, or industrial applications. They are generating IP flow. So this is what is happening over the internet, right? And then there is a user equipment in the other side, which there is another set of, let's say, applications sitting. And then this traffic IP flow should come through the 5G system, which is these boxes like UPF, G-Node B, and UE, should travel and go to the other side. Now, the point is, for some of the traffics, like I don't know, an email, you don't care how fast or how quick or how reliable this packet might travel through your 5G system and reach to this point. So you put it in the best effort. So my packet, the IP flow that comes, I just put it on the best effort, and then it goes. For a Skype video, for YouTube stream, for WhatsApp, it could be applied. But there are some cases that you have high quality of service. So you want to make guarantee of service that if there is a packet to be sent, and if it's a video call compared to an email, I should give priority to this one, and the resources inside of my 5G system should be dedicated to deliver this one first. So this is what we talk about, the quality of service and how to map the IP flows generated here, or it could be different other protocols, right? Even OPC UA things that we discussed. Because after all, in the factory shop floor, you might have different sort of traffics, even WhatsApp calls. People. I mean, the client, let's say the workers might want to use your 5G network to make phone calls. I don't know. I'm just inventing it. So in reality, you have different types of streams of traffic going all through one single network, and how I should prioritize, map them to the quality of service that function 5G offers, and give priority to this. I mean, yeah, this is a big question to be solved. I don't know if at the moment on OPCUA and other solutions, we have this mapping platform between the so-called quality functions identifier of 5G and what OPCUA and other protocols generate. But this is something to be touched upon, because otherwise everything would be treated as best effort. So all the traffic would come, and then 5G would say, yeah, I mean, okay, so these are equal traffic, so I can just decide and pick this packet first to deliver, that packet second to deliver, and this other packet next to deliver. So they are treated equally. So I don't know if I expressed the point in a simple and yet functional way.
Just one comment to add, and I will
Yes.
leave the discussion further because there is a question answer already, and we jumped here. This quality of service mapping in the 5G, it's a perfect illustration for you. Thanks a lot. I think the slides are really like informative. I will again and again refer, I think, in the future. The mapping on the quality of service, when we go to the 3GPP definitions, 3GPP has defined already some predefined QCIs. I think all the guys who are from 3GPP oriented businesses, telcos, know what I'm talking. And 3GPP also realized there are much more services than we have foreseen so far. And they opened a huge range of other QCI. QCI is the quality of service classifier ID. And for each QCIs, 3GPP defined 1 to 9. They have given already some predefined metrics like the preemption capability, preemption vulnerability, the priority level, the guaranteed bitrate, non-guaranteed bitrate, APNs, and all these sort of parameters attached to the QCIs. But when we go this 1 to 9 QCIs, these are limited and mostly talks about voice, video, data, and data is split into sensitive data, non-sensitive data, etc. But in the industrial environment, there are quite a bunch of other type of use cases that sometimes ask for one specific dimension to be like stressed. And sometimes they look for a mix of many different aspects. I think the OPC-UA discussion will open us. I am also curious to learn what kind of requirements are there. And 3GPP therefore opened from 9, QCI 9, up to 256 or 255, if I'm remembering correct. Other QCIs to be specified. And this is actually one very good, I don't know if other organizations already start filling these QCIs with different set of metrics and parameters, but this is very good area as a study item also for us to understand the industrial requirements, map them to the specific QCIs beyond QCI 9, and also map these QCIs to the different network elements on the 5G, on UPF, G0B, even UE site is responsible, like your picture perfectly illustrates, to give the specific parameters as a blueprint configuration for different type of industrial services.
Exactly.
And then we can push this towards the vendors, the suppliers, because 3GPP already leaves the room open. It says, define whatever you want. But then the vendor implementations are key here to make these technologies available in the market.
Mhm.
I think this is one very good point to be further followed. It can even go up to the TSN implementations because of the TTs, the TSN translators.
Exactly.
And it's a very, very relevant and very important topic for our project. I think.
Yeah, may I comment? I think that I bring again a bit pragmatic approach. So I mean, this is excellent. I mean, this is great. We have a lot of technology behind this, QoS, flows, and whatever. But how is this translated into the industrial use case? I mean,
Okay.
if we have like a PLC. I mean, how we can then check, or how the owner of the factory decides, okay, I want to have a certain requirement for this PLC because it's going to connect to another controller that needs to have certain delay, certain reliability. I mean, the owner doesn't know or even doesn't care about flows or QFIs or whatsoever. So I think that we need to, I mean, make it a bit of, or translate this into something that it's applicable into the industrial environment. Because, I mean, in practical terms, yes, we have these flows. We have an application function that you can add new flows with different quality parameters to an ongoing PDU session for existing device. But, I mean, how on earth is the I mean, industrial owner going to decide that, okay, I want this device with this kind of requirements, and I don't care what's happening behind the scenes.
Okay, let me just try sort of an answer here, and I don't know if Arthur is really clarified on after this discussion quality of service. Let's put it simpler. You have an OPC-UA server running in a controller, right? This OPC-UA server in the controller has a simple information model. Let's take it like that. It's not that simple. That it shows how many devices are connected to that controller, right? And how many are alive. And it has some update rate in which it shows that to a client. You have a network and it's just 100 megabit. Let's imagine like that. And somebody decides in that network, hey, it's a good idea to make a backup of all the control system from one computer to another over the same network. And try to see what happens with the OPC-UA client-server communication when you do that. When you fill up the network with the whole bunch of large packet of the whole Ethernet frame size. So those OPC-UA client server frames, if they are not offered any sort of priority, any sort of resource reservation will be very often dropped. At the client, you will see that you lose contact with the server very often, while somebody is doing the backup and so on. So by quality of service, you try to reserve some amount of resources for that communication. Now, in order to do that, you need to be able to say, to describe your communication parameters. You need to be able, also as an industrial automation engineer, to say that I need to talk that amount of frames in that amount of time with that amount of cycle time, and I have a known bandwidth which I need, and I know that I have any and I have n other devices which also have their own requirements. Now, if you don't want to care at all about that, you need to be able to formulate in a standard way those requirements for communication, for the quality of communication, to a network controller. The network controller software takes that, makes the network calculus, and gives the answers.
Exactly.
When and how should be configured. If not, you have to do it manually. You have to know it, because otherwise you have no idea how exactly to parameterize your quality of service. How much resources do you need to reserve?
Exactly. Just to build up on what Mario said, and then also to try to answer to Jose. It's like, so again, of course, we should kind of hide this level of complexity to the upper layers and ultimately to the factory owner. And that's not, but the idea is here just like to show what is going on inside the engine of the car, beside just showing how beautiful is the car and how to drive it in the street, right? So, but again, I think what Mario said is this, it's very important, because as we go to the higher layers, the information expected from the person to be put on the system should become more closer to the human language, more simpler parameters, and then different layers should do translation and calculus properly in order do the and therefore do the adaptation properly and in the underneath layers whatsoever they are, including 5G, to deliver what has been asked in a very simple human language terms. So, and I think this is also a big domain of activity that can be covered and followed and explored, because I don't think yet this exists. I don't think that is yet completely delivered, and I think there is also a bit of gap and kind of misunderstanding between the world of telecommunication and the world of automation. And for sure, the one that needs to adopt more is the 5G world, because after all, they are the clients and we need to adopt ourselves to them. So I think, I mean, whatever we discussed here is quite important. I mean, super important.
Yeah, one question to Arthur. Do you now have your question answered about what to do for an OPCA server running on a device and communicating with the client over a 5G network?
So I think there should be practically somewhere a parameterization of different kind of quality of services for different kind of data or OPC resources, right?
Yes, I mean, you can just ask exactly, you have a parameterization of requirements. You request a given quality of service. If this is going to be guaranteed to you or not, depends on the situation in the network there, the network. Yeah.
Exactly.
Similar is possible in MQTT. In the 4099 standard itself, the prioritization is met by own mechanism normally, so with a handshake from each of the distributed systems. And I'm not sure if there's something inside additionally. This is what I have to investigate.
And maybe it's also a question for Andre and others. Andre, do you know if these things are kind of mapped so far, or is there any attempt to map these higher level things to so-called what we call quality of service in 5G world, beside the one study item that 5G ACIA carried out, which probably just like the first step on this?
Not yet. Okay, it's mentioned in this study item, and then for this mapping, they are planning to have like joint workshop between 5GSA and OPCUA, and it was planned in the middle of November initially, but I think now it's postponed up to December, so it has not been discussed yet.
Okay, so probably this could be a point for us to check and see. I mean, probably if we find something and we can contribute, this could be an option also. So yeah, I mean, well, I think, yeah, again, this is a huge word. I think we are also running out of the time. So if you permit me, I will just speed up. But I mean, that I think that the slide and the presentation served the purpose, because the idea was just like to create more question, to bring us closer to one another, and try to find the gaps as much as possible. So if I may, yeah, so what they did in this presentation basically was to show their use case scenario using a presentation like this. And then here again, we are seeing this quality of service parameter being expressed in you know, a sort of high level language, guaranteed bandwidth I need with bounded latency, right? So, and I was thinking that probably this type of presentation for our trials, this high level presentation of our trials, could be also helping us to better understand, better dig deeper inside what is going to be needed and what is actually missing, and how we can dig deeper. So this is one of the reasons that I think in 2.2 we should have something like this, very high level, to help us better understand who is doing what is missing, so on and so forth. So maybe we don't have it today, but probably we can start building. So just to read this picture a bit, at least again from my perspective, to understand what they represented. So you have a PLC on a stationary robot, and then there is a OPCUA safety. I hope it's, I don't know if it's a well, client or server. Yeah, it's like an element of OPCUA safety, and you OPCUA here, and there is this quality of service requirement that goes over an IP protocol stack and Ethernet, then it goes to an industrial LAN. And here is this 5G system. So you can see the core, you can see the radio, there's a PDU session on top, and then there is a 5G stack on the user equipment side, which is inside this AGV. So this is an AGV that already has a SIM card and it has a 5G stack. And then there is another Ethernet, there is a switch, and then it comes on top. So basically, at the end, what you get, this PLC on AGV is talking to PLC of a stationary robot using a time-critical safety message over this so-called transport link. And then here, this guaranteed bandwidth and this let's say latency was communicated through this QoS requirement to this system underneath, so-called this quality of service requirement of 5G that we discussed so far. And the system here was aware that if there is a packet coming from these guys, I need to make sure that I will give them a guaranteed bandwidth of X and this latency that we agreed. So then these two words match with one another. So again, yeah, maybe this is not yet completely automated. Maybe the factory owner doesn't know how to do it, but I think based on the need of the application, we can also have something to decide. Again, here there is another representation, which is a deterministic and mobile connectivity with OPC UA. Again, here you have so-called a mobile HMI. You have host D, a mobile host C, and then a mobile robot here. So which includes two hosts. So I think for me, the way that I read, host could be, so if this is a mobile robot, this is a portion of the robot that moves up. It could be like a robot arm or something. And then maybe this is another robot arm or something else, which all of them has a sort of OPC UA. So this mobile robot has two elements. There is one element here, there is another element here, and this is a mobile HMI. And you can see there is a 5G network in between that is connecting all of them. And then these guys are talking to each other, these guys are talking to each other. And then, yeah, again, OPC quality of service requirement. So bandwidth and latency to be mapped on different network technologies. And then they try to do this streaming. If I'm not wrong, let me just check. Okay, yeah. Andre, is this one with layer 2, right? If I'm not wrong.
No, it's with layer 3 IP.
It's layer 3. Okay, so everything has been happening over IP. So here everything was happening in an IP world. So what does it mean? It is not necessarily in one single network, let's say. It's not like my local area network in my home that to reach to another local area network, I need to go through a router, right? So there is a LAN, there's a 5G LAN that all the elements here, they can talk. There is another industrial LAN that can talk, and then everything is connected through a so-called router. So here 5G is kind of playing a sort of router role, let's say. This is another showcase that they did, and another one that they did in layer 2, if I'm not wrong. Yeah, this one is on layer 2. So here the role of deterministic networking and this IETF DETnet is very clear. So you can see a clear difference from this one to this one. So here we have IP and IP over Ethernet, but here we have the DETnet, and then it goes over the Ethernet TSN. So this type of representation, if we can work together, we can elaborate a bit more. We can, of course, here there is an emphasis on the 5G, and it was intentional because there was this presentation for 5G. They wanted to showcase something. But what I'm trying to say is, like, with this type of high-level figure, if we do some sort of iterations together, maybe the guys of 5G could express their point of view. The guys of OPC can express their point of view. The guys of platform, they can express their point of view. We will get a more elaborated view or a high-level perspective of our trial scenario. And then we will understand who is doing what is missing. Oh, by the way, this QoS requirement cannot be necessarily easily translated to something underneath. So this is a gap. So probably we can work on it. So it helps us to better understand the the needs, the gap requirements analysis, so on and so forth. So yeah, I hope it's clear what I'm saying, and I hope, I mean, please, if you have questions, doubts, let me know.
It's excellent, excellent view here. I was trying to do exactly the same in the trial for ABB in the North node. So it's just more detailed, let's say, than this
Exactly.
one. But it's exactly this one, this kind of use case, because you see here you have 5G to the device on the left-hand side, and you have 5G, let's say, to a group of devices. You can look at industrial LAN or something like that on the right-hand side. So
exactly,
you can look at from this perspective too. And yeah, I mean, actually in the north side you have the 5G to the level of device. In the lower part here you have 5G to a given industrial automation island, which is called mobile robot or industrial LAN, and industrial VLAN is the one which is above. Yeah.
Excellent. So I hope for the other nodes we can also try to extract some similar views. Or I mean, I understand that maybe not everyone has the expertise of everything. That's completely understandable. But please engage others. Try to do iterations, and then yet after all, as I think Jose already pointed out very well, we need to also keep in mind what is realistic, right? Because we don't want just to deliver some drawings and not be able to showcase anything after all, right? So there should be a balance between what can be delivered, defining the gaps, identifying the potential needs of further improvements, and so on and so forth. So I encourage everyone to take a paper and pen, and probably these things could be reported in D.2 after this high level I don't know, architectural, conceptual thing that we have just reports, this work package works on that, that work package works on that. So I think these type of figures could be very helpful for us to move forward. So if there is no further question, is it clear for everyone? Doubts, questions? All right. So yeah, again, here is another example. So I think we got, but again, I think since the beginning of the presentation, I'm just kind of emphasizing the fact that after all, with this complexity inside of 5G, what is going on, protocols, blah blah blah, what we need to deliver after all for our clients or customers is just it's a logical bridge. Yeah, look, this is just a bridge. I mean, take it as a switch. This is you have, and it supports this and this and this, and that's it. So what is happening inside, it's not your headache. Don't worry, we do it for you. So this should be the mindset somehow after all. And again, yeah, they put some emphasis on this, let's say, OPC UA layered stack architecture. I think we touched upon quite a good number of discussions here. I think like, yeah, with the broker, without a broker, client server pops up. And then here, yeah, you can see here layer 3 quality of service and things. And yeah, I mean here with 3GPP thing. And yeah, that was the question that I asked. Like they put everywhere like TS, well, this is time sensitive communication under 3GPP. Here it goes through TSN. So there is a part that this quality of service requirement coming from OPC UA maps into TSN and from TSN to 3GPP, but there is also a possibility of a direct sort of mapping.
Yeah,
I'm not sure this one is.
Yeah, that's the difference what we were discussing just before.
Exactly.
So you have, let's say, a 5G connection to the automation island, and there from the automation island, from the yeah, you don't have a 5G modem in your end station, in your drive or in your PLC or somewhere. You have a 5G modem, a separate one there, which connects that automation island. So of course, to reach that one, you need to have internally in the island, you need to have the TSN specification, yeah, for the quality of service. Correct. But it can be that you have the 5G modem embedded directly in the end station. This is the second use case. And then you have your rows thing directly, so you don't need to cross over a TSN there.
Exactly. So perfect. But as far as I know, there is a mismatch between the quality of service that OPC UA could request and those that 5G can offer at the moment, right? So there is a room to kind of make a further elaboration on both sides.
Yeah, there is the
Yeah.
3PP specification. I think maybe Jose can talk a lot about that aspect.
Or I think Andre could also help us on that. Or I think is it Andre or Giovanni? Probably Andre or Jose. I don't know.
That's what I just confirmed. They tried to do this mapping, but so far the progress is very limited because they wish to have a workshop jointly with OPCUA and then to clarify this aspect.
Okay, excellent. Yeah, so I think
There was a question. Sorry, there was a question. Sorry, I just stepped off for lunch.
Okay.
I missed the question. Sorry.
No, the point was like that. So we can see that there is a quality of service that OPCUA generates. In some cases, you don't have, let's say, a 5G directly connected, so you need to go through the TSN, and then from TSN quality of service you map to 5G. But there are some cases that quality of service tries to map directly to 5G. A set of quality of service that this word is very annoying because we are both talking about quality of service, and I think they are a bit different anyway. But
yeah,
it
so
seems
I
the
think
number
that
of parameters that
one
this guy
thing-
can request is different from those that this can offer.
Yeah, I think that there's a slight difference because from the TSN, is it the AO2 QB? Or I don't remember. They have predefined QoS parameters, and then in the TSN, they have defined in the 3GPP this TSN application function that is trying to map those QoS parameters defined in the fixed or in the real TSN specifications in the fixed into the 5QIs that are used into 3GPP. So this translation is done by this TSN application function. So that's one option. Then the other thing is that, for example, in the other possibility is to define or to add flows into an ongoing session. So that's what I mentioned before, that you can have an application function, industrial application function, where this OPC controller can request these flows from the 3GPP core, saying that, okay, I want to add an extra flow for this device, and this extra flow, it will have this 5QI. So still this translation between 3GPP Jerga, or the terminology, and the fixed TSN terminology of the QoS needs to happen into this application function.
Exactly. So I mean, but I think we are in a perfect moment to look into this as well, and then try to see if because I mean, many of our companies are also have presence there. So I mean, to see if we can push something. I
think that's something that can be pushed, but but we need industrial players, the ones that push this into 3GPP, I guess.
Yeah, definitely.
Polya, just to add one thing, especially on the 5G pipe, if we want to leverage this real-time QoS adjustment, depending on the negotiation between the TSN-based QoS and 5G demanded or the OPCUA broad QoS, let's say negotiation happened, some sort of negotiation through application, and then this needs to be implemented, and 5G is quite responsive. We can push this with the APIs. I think Matteo Neutron colleagues can give a better idea or more elaboration on this, but just we can leverage these APIs, northbound, southbound interfaces, and push certain QCIs to the network elements on different domains, on the radio or on the transport, maybe less, but on the core and radio, and then see how the reaction on the application passing through the 5G over the air. And this is something can be done already now. I think the APIs are quite widely available, and API mechanisms are also the QCIs are available, and API mechanisms are also there.
Correct. I mean, yeah, definitely. I think, I mean, there are quite. I understand your point, and I think, I mean, yeah, definitely it would be a way to explore and basically to. I mean, let's see how much even we can showcase this. I mean, even if it's just like one step further compared to what is happening today, I think it's already a great achievement. So, but I think, I mean, so far we are kind of canalizing our effort into some right directions, let's say, and then by taking further steps, we just contribute to a bigger journey, because I don't think like in a project we will be able to solve everything of these gaps, but for sure we can just kind of align ourselves to this target and just take some steps towards this. But definitely, yeah, very good point, and I will stay in contact with you guys and Neutron. So yeah, maybe if I can just use the final steps. So here we listed some, let's say, possible enhancement on the 5G core side, on the RAN side, and the, let's say, UE or CPE side that can be done, further enhanced to deserve, to kind of introduce, if you want, or kind of overlap with the industrial world. And you can see there is a huge type of things that can be explored. We just mentioned several. I think many of them has happened already in our discussion, but just to summarize. And this is another, let's say, set of let's say summary of what we have discussed. Yeah, I mean, you can see that there is like 5G and beyond 5G integration on the OPC UA side, like the NPN side, the exposure that we discussed, the business aspect that we discussed. I mean, there is a huge number of questions and doubts to be checked and to be reviewed. Just another final set of slides. So as I stated so far, yeah, so in a normal case, 5G supports delivery of IP packets. In another cases, we support also Ethernet. This one we discussed, so I don't think it's needed. Probably touching upon a bit on the slicing as we discussed so far here, right? So, and then the use of the VLANs and VXLANs over 5G. So let's putting it simple. I try to be quick because we don't have much time left. So basically, normally you do one single deployment of your infrastructure. You just put a set of, let's say, antennas. You buy maybe a core function, and then you have a set of, let's say, user equipment running in a location, right? But on this user equipment, you might run different parameters or characteristics of connectivity service, right? So to reach to a set of user equipments, you might want to give them higher bandwidths, while on the other set, the important characteristic is to reach them faster. So latency is becoming important. And then does it make sense that I should deploy, let's say, several infrastructures to serve all of them? The answer is no, right? So this is the so-called slicing. So to put it simple, think about a cake, right? So you have a cake and you make a slice and give it to your friend, right? So the same thing is happening here. So you do a single infrastructure deployment, you do a cut, a logical cut, and this logical cut gives you a certain characteristics to serve that single purpose, while you still have the same cake available, right? So the single infrastructure is there. It can be served for IoT sensors, mobile data, mission critical services. And then the way to do it are different ways of doing it. Some are reflected here. So you can do it with the layer 3 slicing, so on the IP layer, or layer 2 slicing. Interestingly enough, in the industrial domain, I just borrowed these things from the internet. You can find the link here from Siemens. These things are happening and are promoted by Siemens also. So this kind of, let's say, using VXLAN and LAN. So basically, to just put it simple, I don't know how much we have people with the, I mean, we have a good number of people with the background of network. So, but for those who don't have the background of network, what we are talking about here is like, imagine I have a computer. I have 5 computers in my home. So I could have a local network and buy some equipment and switches and connect them together, right? So this is my local area network, or in short, LAN. But there is possibility that Puria is sitting now today in Barcelona, and there is, let's say, his office is in Stockholm, right? So, but I want to be so-called virtually present in my office, in this local area network of my office. How do I do it? There is a technology, there is a way to do it, so-called virtual LAN. So I can create a tunnel over the internet, and my computer would be seen as part of the local area network in Sweden, as if I am physically there. So just to put it super simple, right? The same thing is happening, and you could have multiple elements in your network, being some PLCs, some other devices, residing in one single LAN. So you can start grouping some of your devices on a single LAN. So local area net. So 5 devices could be in one LAN, another 5 devices could be in another LAN. And this is what Siemens is trying to showcase. I encourage everyone. I'm sure many of you already know that, but just have a look on the way that they are treating these, let's say, VXLANs, how to do the piping, how to do grouping, how some of the devices are in one LAN and while the others are on the other LAN, and then how they are just trying to put it on the so-called private 5G infrastructure. So there is a tunnel that connects these two subnets to one another. So it seems there is gaining a momentum in the industrial domain. Now the question is like how much, how it's relevant to us, how much it exposed changes in this 5G infrastructure yet to be answered. But yeah, I just wanted to bring up this point also. That's why I was thinking that in the community, it would be also nice that we have also colleagues from the other companies that are not necessarily following our project, but could be a kind of a reference point for us to just double check a question or so if we might have. So that's why I always encourage everyone to have an advisory, let's say, and a strong advisory board in case if you have some questions or doubt, we can just like quickly ping someone and maybe ask the question. Anyway, and this is I think the final one. This is just to showcase what would happen after all in a factory shop floor if you want. So there is like a 5G user plane functions and the control plane, and then you have a set of different devices, some of them residing in one LAN, some of them residing in another LAN. There might be some movable items. But then your service should remain continuous. So it's going to be a complex ecosystem after all. We are not yet there. We are not yet fully there, but we are getting closer and closer to this. So it's better to kind of look at some particular points, maybe for our project, to pick up some of those, try to dig deeper, try to, if possible, showcase something in the system level, if I may use, and also, if you ask me, more importantly, try to pave the way for the future by contributing in the standard or reference, let's say, institution and organization. I think, yeah, I just managed to finish on time, I think. Yeah, for the open discussions, I would leave it. Probably we can continue on those on the work package 3 that focuses on 5G, but from what I heard today, probably there would be a very good overlap between work package 5 and work package 4, that when it comes to the interface between the different words. But I would say we should follow this cycle of why it's important and how it's doable. So we should just always jump between one another to answer or questions. So that's all from my side. Yeah, I think it was quite intensive, but I think it was quite fruitful and interesting too. So if there is any feedback, if you want to express your feeling about the session, please feel free to say if you like these type of sessions, if you think it's useful for us or it's just waste of the time, I don't know. Just please feel free to express. If not, we can maybe start closing the session. Yeah.
Maybe I just jump in and use this opportunity to give my thanks. Purya, this was an amazing session. I fully enjoyed it. I learned a lot of things, and I would definitely keep doing this kind of sessions because it closes the gap between different expertise domains and partners in the consortium to get closer and to better understand and to better focus on the main target.
Absolutely. This session also fostered the communication among the partners that can only be fruitful for the project.
Absolutely. Thanks a lot.
Really interesting from my side also. Thank you very much, Julie. Can we find this presentation in the next cloud? Or
no, I will share it. Yeah, I will put it on the next cloud. Yeah.
Right.
And by the way, the session has been recorded too. So it's
also okay. Thank you.
So
thank you very much for organizing it. I think it was very helpful for everyone to be on the same page and to learn a little bit of topics outside of our domains. So thank you.
Thanks to you. Thanks to you. And I hope, yeah, in the future we can continue maybe another, let's say, kind of outlook from the other angles, like probably more on the OPCUA side or the platform side. And then I don't know, if we find it useful, we can go even in the particular cases. Like, for example, there was a point related to the network management from OT world and network management from ICT world. So it's also already a huge thing to be discussed and to be checked. And I don't know if it's needed, maybe we can do later on some sessions about that. But anyway, so I don't want to steal more time from you. Well, thank you very much for all the good contributions, for all the comments. I hope it was at least a useful morning for all of us. And yeah, let's continue the good work. And yeah, hopefully we can get the best out of this project altogether. So thank you very much. Have a wonderful rest of the day. And yeah, thanks.
Thank you. Thank you.
Thank you very
Thanks
much.
a lot.
Thanks.
Yeah.
Thank you all. Thank you, Purya.
Bye.
Thank you.
Bye bye.
Bye bye.